Please welcome to the stage, Parisa Zari from Meta.
Good morning, everyone. Welcome to At Scale Product 2025. So excited to have you here on our beautiful campus in Menlo Park, and a warm welcome to everyone joining us online. I am Parisa Zari, and your host for today. I'm a technical program manager at Meta, and I lead developer productivity at Facebook. This is the fourth and final At Scale event of the year, and it's a super special one, as we've been able to bring 4 tracks into one conference. Those tracks being RTC at scale, video at scale, mobile at scale, and product at scale. And we're able to do this thanks to the power of AI and how it's transformed the way we build things at scale. These areas are interconnected more so than ever. AI is having a moment, isn't it? But how much of it is hype? And how much of it is going to stick around? What I do know is that we haven't seen a transformation this big since the mobile era. But the transformation with AI is much bigger and faster and deeper. AI is radically transforming the way we think, design, build, and execute. Speaking of mobile, do any of you do this? Go through your mobile apps and wonder which one of these apps is going to stick around, which one of them will fade away, and which one of them will be totally transformed by AI? Well, that is the same level of curiosity that I want you to bring to the event today. While listening to the talks, think about how AI is going to change the way we build things at scale within the next year or 2 or even 10 years. Speaking of talks, we have a jam-packed day today. One of my favorite product people, Ime Archibong, is going to kick off the event with a keynote. Ime is a product leader at Meta, and he leads the product teams for social engine AI for Facebook and Messenger. Afterwards, we have a series of technical talks by brilliant engineers and product leaders across the industry. Meta, Microsoft, LinkedIn, NVIDIA, Canva, Agora Labs, AudioShake, just to name a few. We then have 2 panels, one on privacy, which is super relevant given where we are with AI today, and the other one on wearables, which I'm super excited about given what we just saw from Connect. There is a chance for the audience to ask questions. There'll be a QR code. Right now, you can scan this QR code, and you'll be able to ask questions at the end of each talk. You also have this QR code on the agenda for those in person on your seats. There'll be chances to scan this QR code again throughout the day. So my advice for today, stay curious, ask questions, network, get connected, and try to have some fun. With that, please welcome Ime to the stage. Please welcome to the stage Ime Archibong from Meta.
Good morning, everybody. How's everybody doing? Awesome. All right. Well, it is an honor to be here to welcome you and maybe ground you guys in a little bit of the intersection between the transformative change that AI is ushering in and something that I care deeply about, which is our basic human needs. If I ever get the opportunity to talk to somebody in my office at home on VC, they tend to notice a bunch of posters and photos that are behind me. And this is the one that I probably get the majority of questions about, and it is Maslow's hierarchy of needs. I'm sure many of you are familiar with it. But as someone who's responsible for building products that touch billions of people, frankly, every single day, what I have found is that Maslow's hierarchy of needs has served as a pretty extensible and kind of durable, abstract kind of framework for me to think about the universality of who we are as human beings and what our needs are and what ultimately the technology and the innovation that we're all pushing get the opportunity to address. Now, if you put aside any of the academic or the historic kind of concerns or criticisms of Maslow's hierarchy, I actually do think that we all probably can agree that it's directionally right. Like once we as humans get the opportunity to breathe and eat and drink water, once we are psychologically and physically safe, that immediately our deep desire for loving and belonging and human connection tends to kick in. And for someone who's been building social products for a few decades now at this point, I spend a lot of time thinking about that particular zone. Our deep desire for human connection, it's just like something that is inherently human, and it drives a lot of the innovative tool building that we as humans have done over the course of many, 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 many years. I like to remind people that community, like community and communication, share the same Latin root word, which is to mean common or to share by all. So as long as we have been tool builders, and as long as we as human beings continue to try to advance our desire for community, we have been building communication tools. The first, or one of the first great minds to start to talk about this in kind of an academic realm was a Canadian professor, Marshall McLuhan, which I'm sure many of you are familiar with. In his 1960, I think 64 classic, the book Understanding Media, he coined the phrase, or the phrase that people repeat the most often is, the medium is the message. And what did he mean by that? He meant that the medium with which we use to communicate to each other is actually more impactful to us as individuals, and then at scale to us as a society or to culture, than the actual message that is being sent across that medium. So for about a few dozen chapters, he walks through all the different communication innovations that have happened since the beginning of humanity, right? Speech, he talks about the telegraph, the telephone, printing press before that, but ultimately in the 60s, he ends with kind of the newest technology, which was the television at the time. And while the book is fascinating, and if you haven't read it, you should read it, especially if you're someone who loves communication tools, as we're sitting here right now, and today's world of things that are transforming and changing, the chapters that I actually find the most provocative and the most interesting are the intro chapters, so chapter 2 and chapter 3, where he introduces this concept of cold media and hot media. So media, by the way, the plural of medium, which is the actual tool with which we use to communicate with, not to be confused with media. For cold media, he tends to talk about, these are mediums where if I pick up the phone and you pick up the phone and we're having a conversation, we have to participate, we have to engage, we have to interact using the medium in order to get actual meaning from it. The example that he used back in this book was the telephone. For hot mediums, these are mediums that ultimately you don't have to participate in order to get the meaning out of it. You can sit, you can consume. The example that he uses in the book predominantly is the radio. You could turn it on, you could get the broadcast from DC or New York or wherever ultimately was pushing out that message to you. But you didn't have to participate actively in order to get meaning from that. Now, a provocation that we'll visit a little bit later that McLuhan puts out there is that the type of medium that we use, especially at scale, again, will have a disproportionate impact on how we as human beings feel connected to each other, or frankly, the lack thereof, feeling connected to each other. And then McLuhan, again, 1967, he was talking about scale, he was predicting kind of the digital future and what was going to happen, but he never actually saw it himself. So while he never saw the digital age, I don't know, and I'm very curious to see what he would have thought about some of the mediums and the tools that we've built over the course of the last couple of years. I wanted to walk through a couple of those really quickly with all of you. The first is, McLuhan lived into the 80s, so he lived long enough for any of us 70s and 80s babies or folks who were using technology back then to see kind of the first dawn of what I call social online. And these were broadcast bulletin boards. Many of you will remember them. They were brought about because of the advent of the modem, connecting with early computers. At its scale and at its max, bulletin board systems probably reached 20 million people around the world every single month. That was it. It was great for maybe the 80s. Fast forward to the 90s, broadband internet, and what that made way for was social networking as we probably know it today, right? You get the MySpaces, you have the Facebook that emerged in the early 2000s. But ultimately, the scale that has been brought forth because of broadband internet and social networking, this is what I call the second era of us as human beings connecting and finding community online, has been rather large. We're talking about 3 billion people every single month right now. Pretty profound. Last but not least, for the folks that I see out there that are probably a little bit younger, you clearly remember the 2010s and what mobile brought about. And again, this is what I consider the third era of being social and connecting with people online and communicating online. We're talking about messaging as we sit here today. Over 3 billion people every single day, frankly, their deepest social interactions are happening in iMessage, in Messenger, and Instagram Direct and WhatsApp and Snapchat and Telegram, you name it on down the line. But messaging right now is the container where our deepest social interactions are happening. And again, larger scale than the previous two eras. The patterns across these different eras for you to think about and that I think are pretty exciting for anyone who loves communication tools or mediums is first and foremost, each one of these new eras was brought about by a transformative technology. So I talked about the modem, I talked about the broadband internet, I talked about mobile. The second is that I won't go into details on this, but every single era built upon the successes of the previous era while also fixing some of the limitations of the previous era. And as a result of that, what you see by these S-curves is that more and more people were able to find community, to communicate, and to do what we frankly do in real life online, which is connect with each other and have social experiences. This pattern, and kind of the three things that I just walked through, is why I'm frankly really, really excited about where we're at right now, and I'm sure many of you who also love communication technology are pretty excited, because we're sitting here today at what I think is probably the precipice or the beginning of the next great social era, right? And it's brought about clearly by this current phase of AI, and what we are all, probably pretty excited about and thinking about how we are going to build products and experiences for. What I don't know is whether this next S-curve is going to be the S-curve that allows us to reach what, if you got the opportunity to walk through the meta halls today as you made your way in, you probably saw things like serve everyone, which has kind of been our North Star and one of the principles with which we've built products for over the course of the last 21 years. But regardless of whether we're going to tap and find the next 4, 5, 6, 7 billion person social product right now, I think very relevant to this audience and something that's pretty exciting and I think pretty fun for any technologist to geek out on is the amount of scale into the infrastructure that is being put into place right now in order to unlock that next S-curve. So I thought, again, it'd be helpful and fun for us to take a little trip down what's happening right now and what real scale looks like. Scale under the ocean, that's where we'll start. New subsea cables, right? These are the glasses of strands of glass that are ultimately connecting and being the backbone of every single continent when it comes to the internet around the world. Earlier this year, we announced what we called Project Waterworth. Project Waterworth is a multi-billion-dollar, multi-year investment that we are making in order to lay fiber, right, high connective fiber, advanced technology fiber, across 3 different oceanic corridors that you can see in this image right here that connects over 5 different continents. And when you think about the scale of this, 50,000 kilometers of subsea cables are going to be put into place when this project is all said and done. So again, for scale, that is larger than the world's circumference, right? So pretty profound, pretty exciting, and I think for anybody who is excited about the abundance and like the ability for AI to hopefully transform lives and transform how we as society operate, the fact that we are doing something at this level of scale is exciting to me because it means that the people who will be able to take advantage of the technologies that we build aren't going to be limited to certain geographies, locations of where they live or where they work. And that's massively exciting. It's not just undersea, as we all know. There's a bunch of efforts, and I'm sure many of you are putting into efforts building the above ground infrastructure, which is also massive. Last December, we announced that we were building our largest data center in Richland Parish, Louisiana. Don't be confused by the photo just yet. But this is the data center that's going to come online. It's going to be a part of the global infrastructure that many of us in this room are building right now over the course of the next couple of years to really power our AI ambitions and the things that we are mostly excited about. This particular one is going to play a vital role for us. It's going to have and be able to deploy over 2 gigawatts of compute power to power a lot of the open source LLM models that we're going to continue to train and invest in over the course of the next couple of years. And then hopefully the products that we are extending to billions of people and the inference capacity that's needed in order to pull that off. To contextualize the scale, we did this image. It is not going to lay over Manhattan, but we figured that it would be a good way for people to understand the size and the scale of what we're actually trying to do here, which is pretty profound. I am a runner. I love Central Park, and the fact that this thing is like 2 or 3 times Central Park blows my mind, and I'm looking forward to visiting it and maybe get a nice marathon run in when I get down there. But you see the above ground infrastructure and the scale and the capacity we're putting into place. We talked about the underground stuff that's happening right now. Again, we are all making these investments at this large, massive, unprecedented scale without a real strong, like, what is going to be that 4, 5, 6, 7, 8 billion person product that we are trying to build right now. Now, Similar to probably many of you, I have a few hypotheses. We as a company have a few hypotheses, so I thought it might be worthwhile to walk through a couple of those hypotheses of what we're trying to build with this infrastructure and this scale, not surprisingly grounded in Maslow's hierarchy of human needs. The first is AI is going to transform our conversations with each other. We're already seeing it, right? AI is unlocking the ability for us to have a conversation with anyone, frankly, around the world in real time in a pretty profound and powerful way as we reduce the language barrier. So I have a clip here that I'm going to show you from a Jimmy Fallon episode where Jimmy is having a conversation with a native Spanish speaker.
Hola, Sofía. Hola, Jimmy.
Hola, Karen. All right, so we'll turn on the translation feature. I head to Call Assist, Voice Translate, choose the language, and...
Call is translated by Google AI. In each speaker's voice, audio is not saved.
Hi, Karen. Can you hear me? Does this work?
Hola Karen, ¿puedes oírme? ¿Funciona esto?
What's up? Hello. Yon. I'm the crazy person listening to you in Spanish.
Okay, this is really cool. I can't believe how fast it's working.
Esto es realmente genial. No puedo creer lo rápido que está funcionando.
All right, this is the technology of sci-fi books, and any geek has loved things like what we're chipping away at now at this point. So super exciting. At the end of the day, it's not just about the quantity of conversations that we have. Like reducing the language barrier allows hopefully 8 billion people to communicate to each other. And I imagine a world where that is right on our fingertips. But it is also about the quality of conversations that we can have with each other. So I'm going to show maybe a video in the background and explain what's happening here. So on the accessibility front, there was a team that focused on, of course, integrating AI into our Ray-Ban Meta glasses and the hearables technology to better attune our place in areas in space where these two people are at a nosy restaurant, gentleman's looking around, wants to focus in on his friend's conversation, and activates, as you see here, conversation focus, which is a feature for the Meta Ray-Ban glasses that effectively cancels out all the noise from the surrounding area and really allows him to hone in on the person that he is trying to have the conversation with. Again, in a world and a place and a space where not only we're having more conversations, but we can have better conversations because we can be better listeners, I think is profound and pretty exciting to me. Moving on from conversations to content, which is our second hypothesis, which is that ultimately AI is going to transform our relationship with content. Right? We are entering this wonderful, wonderful age of content freedom, where content is more dynamic, it's hyper-personalized, it's interactive, a lot of things for us to be excited by. I won't belabor the point here, but I think on the consumption side, we are seeing a lot of interesting things. Upscaling, or what people are calling uncropping of photos and videos because of AI, fixing resolution, clearly the generative power of AI and what you're able to bring to life. You'll frankly hear more about this over the course of the day, and I think that there's actually a super resolution talk a little bit later today. One of the things that I think is more interesting, maybe even the consumption, which I know is dominating the industry conversation right now, is ultimately what this is doing for creativity and people's ability to be creative. It is creative superpowers bringing more and more people's imaginations to life. I'm a dad. I have a 4-year-old son named Amari who is precocious and verbal and interesting and hyper creative. And every single night before Amari and I, or Amari goes to bed, frankly, I whip open, whether it's Gemini, whether it's ChatGPT, you name it on down the line, and I let him just explore his creativity and bringing it to life. He's a 4-year-old that's obsessed with animals right now, so more often than not, he's like, paint a vision or a scene of 2 animals playing some random sport, whichever was the sport that he played at school that day, in some random location. This is joy. Like, I enjoy reading books, and we read plenty of books together before he goes to bed, but being able to do this and see him take his creativity and bring it to life in a way where he's always like, ooh, that is so cool, is just something, frankly, I was not able to do as a 4-year-old. Frankly, as someone who is in his 40s now, I can't draw, so I can't actually bring my things to life and my creativity to life. But to see him go from creativity to actually bring it to life really quickly, I think is pretty profound. And I think it will benefit us as humans, as a society, when we get more and more people being able to bring their creative minds to a place and a space where they can share it. But it's not just about images nor videos that I showed before. I'm also really fascinated and encouraged by concepts like this. So this is Gizmo. If you guys haven't downloaded this app or played with this app, a small team moved away from Snapchat and started to build this out using AI. But essentially, they are democratizing coding. They're allowing you to go from words and a few sentences to actually creating a widget that is a game or that is an interactive unit that you can play with and share with your friends or your family or frankly, the public in the world. Again, like, I am a CS major, but many people in my life who are probably way more creative to me are not CS majors, so their ability to build games or to build websites or frankly to build any type of product would have largely been limited. But you have people like Gizmo and other people exploring different ways to make sure that we can bring people's ideas to life in content. The last hypothesis that I'm going to close out on is probably the one that I'm most interested and exciting on. It's potentially maybe the one that's most provocative, but it's AI is going to change the quality of our connections, right? Our relationships with other people. There's a whole category of startups here in the Valley and frankly around the world right now that are trying to pull from your digital footprint and your digital network to ensure that as you get into conversations or you're trying to connect with someone, they can facilitate that in a way that's not only easier and more efficient, but prepares you for that connection and that conversation in a way where you can okay, here's the meaningful mutuality or the thing to connect with this person on to make sure that we can build trust fast and have a more meaningful dialogue or conversation. In my opinion, these things truly aren't replacing connection. They are really enhancing our ability to connect with each other, and I think that's pretty profound. The angle of this, which is a little sharper and maybe a little harder to grok sometimes, I actually do feel like AI also is unlocking our opportunity to know ourselves a little bit better and our relationship with ourselves. Many of you guys will know Reed. Reed is founder of LinkedIn and a VC here in the Valley. He has been tinkering with a bunch of different AI models over the course of the last, frankly, year or two. In this particular case, I'm not going to show the video, but Reed stitched together, a large language model, a video kind of avatar, photo to video model, and then a synthetic speech model, so that he could have a conversation with himself from college. Again, once we as humans have our physiological needs met, once we have our safety needs met, once we have our social needs met, then there's the creative needs on top of that, our self-esteem needs. The last kind of highest, deepest order of kind of human need that is in Maslow's hierarchy is self-actualization, our ability to understand ourselves, be the best version of ourselves. And one of the awesome powers and kind of promises of AI is people to take a bunch of different data, a bunch of different input and context and synthesize and help you understand patterns and insights. So imagine, again, another powerful tool for you to understand yourself a little bit better, see kind of some unexpected insights about yourself, have the conversation, be able to reflect and continue to grow as a person. I think that if we can chip away at this and make some interesting tools, the fact that we could give maybe every single human the ability to know themselves a little bit better, understand themselves, and help themselves grow is and could be one of the most powerful gifts that we give to humanity. This brings me back, in conclusion, to McLuhan, and to talk a little bit about the importance of connection, right? So I mentioned up front that McLuhan gave us this dichotomy of hot and cold mediums. Cold media draws us in, it forces us to participate in order to get meaning from it. Hot media is a little bit more consumption experience, it's a passive experience. His warning in those early chapters was also very, very clear, and I said it up front, which is ultimately when the communication tool does too much of the work for us, right? When it is one way, our ability and our feelings of connection as two human beings starts to wane. And again, when you do that, not just at an individual level, but at scale, right, the digital world was going to bring, it also questions or starts to compromise our fabric of humans, of society, and so on and so forth. So I'm not sure if McLuhan would have seen some of the examples that I just showed you, what he would have said, whether it's hot, whether it's cold media or not. I have my hunches and my inclination. But one of the things that I really do enjoy about being here at this company, at this state and time, is that we as a company, Meta, we deeply, deeply believe, and we've always believed, that our job and our responsibility is to further the future of human connection and to build the future of human connection. Frankly, as the world's largest social network and a network or a company that owns properties that touch over 3 billion people every single day, almost 3.5 billion people every single day, we have the opportunity and probably the imperative to ensure that human connections thrive as a result of AI, not despite it. So you've heard us more and more start to talk about our vision around personal superintelligence. This is a superintelligence that understands your goals and helps you achieve your goals, helps you navigate your social life, help you be a better person, partner, friend, community member, neighbor, you name it, on down the line, and then ultimately helps you be a better version of yourself. This intersection of the technology that we're building in our Meta Superintelligence Lab and everything that we've done at this company for so long ultimately is going to be, in my opinion, one of the important and most important North Stars that we as an industry, definitely we as a company, and hopefully individuals are keeping in front of them as we're building out this technology and putting things to work. So I want to pause there. I want to just say this is the future that we are building towards, that we're really deeply excited about. It's a North Star that we have here inside this company. It's a North Star that I hope many of you out here ultimately have for yourself. I hope you enjoy the rest of the day. And with that, thank you.
Please welcome to the stage Steph Carrazza from Canva.
Hello, everybody. It's so nice to be here today at Progress Scale. We are living in an incredible convergence between creativity and AI. This is what we refer to as a new creative renaissance that has incredible possibilities where basically the sky is the limit. So last weekend, I was driving home with my kids from a trip, and we do this game where we take turns and we tell stories, and so the parents don't have to be always the ones coming up with them. And so my 4-year-old was like, "Hey, can I go first? And can we make a movie out of this?" I'm like, "Sure, yeah, we can try." So she goes, there's a princess, of course. She's riding a rainbow unicorn. Okay. The rainbow unicorn is galloping on top of a rainbow. And then she has a sword, and she is fighting a dragon that is spitting fire. So I go through the list, and I'm like, okay, so we have fire simulation, we have quadruped animation, we have a lot of like alpha channel compositing on the rainbow that is transparent. I'm like, yeah, this could be like a 2 weeks worth of work. I did some VFX and animation in my previous life, and I was like, whoa, like what a crazy opportunity now to actually go home, prompt this. We did a few tweaks, and then it came out, and it was pretty good, and she was so proud, and she showed it to the grandparents, and she thought they had to pay a ticket because it was so good that it deserved it. And so this is just an example of like the incredible empowerment that AI can bring to creativity. And then at Canva, our mission is to empower the world to design. We want to empower everyone to design anything with any ingredient in every language on every device, and also to publish it everywhere and be able to share it. And AI is just really like an engine underneath that is making this mission a lot easier for us, and is really pushing to the full extent. Our community has already reached 240 million monthly designers that are using it to create, and then more will come as we extend all the capabilities, leveraging and harnessing the magic power of AI. Just a quick intro about myself. I started here in the US as a Stanford researcher, doing machine learning for animation, computer vision. That led to a startup, Mixamo, where we were using machine learning to animate characters. And then I spent the last few years before joining Canva developing the industry's first AI assistant for game development, Roblox. I've also had some artistic parallel life there in VFX, film, animation, and 3D interactive art installations. I'm a designer as well, so I'm close to the community. I'm so humbled to serve. And then I recently joined Canva as the head of AI research. It's a new division we put together this year to really focus and harness on AI for creative workflows. And Canva also acquired Leonardo.ai, one of the leaders in this space, a company that developed also foundational models. And so we, together with a lot of the talent coming from Leonardo, we formed the AI research division. And that's where we are going to really focus on bringing the power of AI into the creative workflows. If you zoom out a little bit, if you look at the evolution of AI capabilities, and if you weave through all the noise and all the announcements that every day come out about a new model, a new capability, you're going to see basically there are 3 stages or 3 steps that usually AI capabilities go through. And then each type of asset kind of has its own story. So we have seen the evolution of image generation, maybe the fastest one that is already like a step 3, where at the beginning, I still remember the day when I sat down in the OpenAI office and I saw, the avocado chair, DALL-E 2, like that felt like totally magical. And people were like, can I just try it in any possible form? But then later on, people wanted to have it more integrated in their day-to-day. Then they wanted to have it integrated in their day-to-day tools, so whatever comes out of AI can be edited with tools they are like familiar with. And so over time, we go from like this complete breakthrough all the way to full integration into the workflow and also collaboration, right? Working with the team, not just in isolation. We are seeing video moving probably at this time from between step 2 and step 3. Image, as I said, is already in step 3 of the evolution. Some of the earliest word generation capabilities that we have seen emerge with like a Genie 3, Mirage, and those are already still stage 1, where like it's already a miracle that this thing is working, that you can use just AI video models to generate 3D word where there's physics, but of course it's not as accessible, it's not integrating workflow, it's not editable as it will become in the future. And so when you see all the noise that is going on in the AI ecosystem, there's also a lot of fragmentation. And ultimately, designers and creators, we serve also broader categories than designers, as we introduce also Canva Code recently. So you can generate code and websites and so on. And so we want to really help them do the work they want to do and kind of weave through all the fragmentation and the friction and the noise. And so our goal at Canva is to really have a future of precise control, which is not exactly what you have today, where some of those prompts are like a page long to get what you want. Instead, we want to craft a whole new class of tools that allow people to provide to AI the feedback in a more intuitive way. Prompting was great. I mean, this is where we all started, but ultimately the creative process is fundamentally iterative and also multimedia as the input. And so that's what we are looking for. At the same time, we're also trying to have a future of simplified workflows. So this is an example of what that is not currently. It's a great Canva AI workflow that I use actually from one of the videos that we're going to see later. It provided like incredible flexibility to people that were prototyping ideas, or they wanted to connect the latest open source model and create a workflow. Great prototyping tool, but ultimately the goal is to really abstract above the complexity and provide to people things that are more accessible and don't need like deep technical knowledge to achieve the goals. And so the 3 problems that we have seen in the industry, there was a lot of focus on like the creative step itself instead of everything around it. And so artists and designers felt also threatened sometimes. And instead of like focusing on like the mundane, repetitive task where you want to, I don't know, resize an image in 20 different formats and aspect ratio to target different websites and different type of advertisement, for example, that's work that most people don't enjoy doing, right? And we don't want to instead replace the creative part. We want to actually complement the creative process. We also have seen a lot of AI coming out where it's disconnected from the tools. So AI is great if it gets you to, let's say, even 80%, as long as it happens in a place where then you can take it to the 100% with the tools that you have. And if not, it stays at 80%, and that is just not enough to do the job. And so the goal is, again, to create a complete workflow. And so that is what we've been pushing. And we have a Canva, a 3-pronged approach to AI. We are developing our own proprietary models, foundational models when it's needed, especially in the design space. We also partner with the best-in-class models that are out there, LLMs and everything that help us put together like a full solution. But we also have on our platform creators that make AI apps, and we have right now over 150, and it's growing, so that the community itself can make the AI tools for the designers that we are serving. If you're looking at the journey of AI, Canva, it started in 2017, where we introduced AI-powered recommendations. All the way to 2025, this year is the one where we have launched the most AI. And we're not even done, because in exactly 10 days, we will have our largest event and probably our largest release ever, with a lot of AI capabilities coming. What we launched earlier this year was Canva AI, Canva Code, Canva MCP Server, and a lot of capabilities. But again, the journey is just becoming more and more productive on that front. We have worked on some of those for several years, and now they're all coming to fruition. So we are very excited to continue that push on the upper right of simple and easy and not much time. That's the sweet spot, and that is where we are really trying to harness AI to get that turbo boost for our mission. A few examples, practical example about how we integrate it in the workflow. Magic Media, here I can prompt the generation of images, graphics, videos, and more asset type coming in the future. I can drag them directly in my editor, and there I can do all the changes that I want. So I have all the tools that I'm familiar with at my disposal, and once I generate, I can just take them to, again, from the 80% to the 100%. Another example is the Magic Studio for photos, photo editing. Here I can just use AI to separate the foreground and the background, and then in this case, change the hue of my foreground and really get what I want. So all these tools are AI, where basically AI is integrated in the workflow itself, and that's why we found usage feels just natural. Actually, the user doesn't even need to know this is AI. It just does a better job than what we had before. There was no, based on deep learning, and just all the tools just get better overnight. Another example is Canva AI. The nature of the creative process is iterative, as we were discussing earlier, and being able to have a conversation, of course, makes sense. And so in Canva AI, people can iterate, in this case, on a travel brochure, and then once they are happy about the output the Canva AI is providing, they can just click one button and then edit in their document editor, and then go into like changing the text, the font, all the like fine-grained changes. So these are just 3 examples of how we have integrated AI into the workflow, as opposed to trying to do the other way around, where you start from AI and then you're trying to build tools around it, which is a more less intuitive and less natural flow, I would say. If you look at workflow in a broader sense, ChatGPT is in many ways the start of many of those workflows, where people have an idea and then start there, type in something, and then ChatGPT can provide some suggestion, and in some cases it's basically the start of a project. And so we have announced at the Dev Day keynote, OpenAI keynote just a few weeks ago, the integration between ChatGPT and the Canva app. So you can start creating directly in ChatGPT, and then take your creation directly into Canva, and then edit it, and then take it to the 100% that you want. So that's another example of this trend of like bringing AI into the workflow. And one huge disruption that we are seeing now is what is happening in the video space. The video space has been for a long time a place of deep expertise, very complicated tools that take years to master, and not accessible to everybody. And this is really about to change. As I said, we are in this incredible new creative renaissance, and we are seeing things that used to take days, if not weeks, now be done in a matter of seconds. Here I have just a few examples to show you. They are like very classic of like VFX or video editing, object insertion. which for images is pretty straightforward. This has been around for a while. It's a lot more complicated for video. But now we have even open source video models that can do that in a matter of seconds. Same for object removal, which is often something that is needed to remove clutter from the scene or to actually place the product that I want to talk about on my main character. Those are just two simple examples. There's actually more out there that is really fun that is coming up. We are doing a lot of experiments on like completely new workflows to edit video. So the top left, the one is playing now, we are seeing a photo of the Colosseum, and then we are seeing on the top, there's an animation that I've taken with my iPhone of an object on a table. And then I'm able, just in a few seconds, to transfer that camera motion that I did with my phone over an object to the image, and also to outpaint the image. So I see also parts like the trees and the lamppost that were not even there in the original photo. So this type of work, if you were doing like in original, with original approaches, you will have to do camera tracking, you will have to reconstruct the Colosseum in 3D, you will have to add all the content around it, and you will have to take the shot and render it. This shot alone would have taken probably a few days at least for someone who is relatively expert. The one below is scene replacement, which is another one that is helpful. It's not just the backdrop. You have to also change the lighting on the object itself so it feels integrated in the scene, so that is a little bit more complicated. And then the third one is an animation, which is probably the hardest form of art in the video space ever. So I'll just play this quick clip.
Hey, weren't we supposed to do math homework together last night?
Oh, totally. And in fact, I was about to call you when I got abducted by aliens.
Alien abduction.
So this is just an example of a clip that to create this 10 seconds of animation, this would have taken probably like many weeks. And the lip syncing is quite incredible. This is all coming from a single image and some text. The text got converted into audio speech. The speech is driving the animation and also the gesturing of the character, which is quite good, I would say. And now imagine if I am a Pixar or a movie studio and I want to create my animated movie in every language in the world. The amount of work to redo the lip syncing in every language, I think, is probably something that will no studio will ever want to do. But now with these new capabilities, I can actually feed the translated speech to the same animation pipeline, and I can get this like localized and culturalized in a way that was never possible before. So it's really like a new renaissance for video, I think. We see a lot of really hard 3D problems solved by 2D video models that are becoming more and more powerful. Control and consistency are still the top ask, and it's going to be like that for a while as we add more tools and more features so that creators and designers have full control of their creation. And then this is also an opening for completely reimagined user experiences, because we don't have to drag along all the technical complication of the past, but we can really reimagine how people can create in this new era. And the one take-home also message in this incredible times that we are living is, as models change and get better, as new models come up, and there's a lot of like AI that feels in flux and really like happening at a very fast pace, there are some key investments that every company can do to actually harness that, and those are defensible, and they also provide value in the long term, which is investing in a way to evaluate those AI models. And so there's typically, simplifying a little bit, there's typically 3 levels of evaluation of an AI model. The first one is basically done by auto-evals. Everybody should have a large amount of regression test, integration test, where they can basically measure what AI can do on a set of problems that are curated by the company. So this can run very quick in a matter of minutes or hours or overnight, and in the morning tell you, okay, this model is promising. Then sometimes we go to the second stage, which is human evaluation, where it takes a little bit longer, but it's a more accurate representation of the value to the user, and humans are in the loop. And then the third one is A/B testing. So you get 1% of traffic in production routed to this new model that already has passed 2 gates, is promising. And then there you can see if it's actually moving the needle for the user, if it's improving retention, or if users are more effective, and so on. And then this iteration, the faster you can make that iteration, and the more you can push the organizational velocity, the faster your company will be to adopt any new trend, any new model that will come up, and you're going to stay always ahead of the curve. So this was the last thing I want to talk about before a reminder that there is a Canva World Tour happening in exactly, it's happening now this month, but there will be a final keynote happening on October 30th, where we are going to announce a lot more AI and a lot more new creative tools and features. And thank you so much. I cannot wait to see what you all will create. Thank you. I think now we have 2 minutes for questions.
So we have a couple of questions from the audience. One audience member asks, using AI in Canva, will you be able to combine different types of assets, like images, videos, code, etc., as opposed to generate just one type at a time?
That's a great question. So as models become more multimodal and more powerful, we see this scenario where some of the image generation convert into video. We have seen actually a lot of features that are image to video, for example, where you can basically design your whole story as a storyboard with just images, and then at some point you want to convert all that into video, or in the future you want to convert that into an immersive experience. And so I think going forward, this is something we are actively looking into that. There's going to be more of a porous boundary between all the asset types, and things will flow in and out of them, for sure. Thank you.
And then we have one more question. Are you guys planning to add AI generation of 3D objects and scenes on top of images and graphics and video asset types?
That's a great one. For the full answer, you probably need to wait until the keynote of a Canva World Tour for that. But just looking at the trend, we have started with like presentations, documents, video, right? And we have expanded with like spreadsheets, code, websites. And so we are aiming to empower our designers to target every type of asset out there, every type of experience. And so that will be just a natural evolution of what we do. Thank you.
Thank you. And if we can get one more round of applause for the speaker today. Thank you.
Thank you.
Please welcome to the stage Jaime Del Palacio from Meta.
Good morning. Welcome. My name is Jaime Del Palacio. I'm a software engineer on the Instagram virtual reality team. And I'm very excited to be here today to talk to you about spatial media in Instagram VR app. Over the next 20 minutes, I'm going to share with you the journey we took to make Instagram a true VR experience, some of the challenges we faced, and the approaches we took to solve them. But first, I want you to imagine that you have a VR headset with you. You place it on your head and enjoy the clips I'm about to show you. These are some of the ways that you can enjoy Instagram VR today. You can pin your IG experience to a virtual wall on your environment. Or you can enjoy it in mixed reality in your living room. And if you notice, all the content in IG is in 3D. But how did we get here? In 2024, we set out to build a native experience for Instagram in Quest. We wanted to supercharge the VR experience, the social experience in VR, and what better way to do it than through Instagram? By October 2024, we had launched our first version of the app. It had the basic functionality that you would expect from Instagram, a home feed, stories, reels, profile. But we wanted more. We wanted to really supercharge the VRR experience for IG users. We wanted to bring IG content to life. Basically, we wanted more immersive Instagram and amplify the social experience. We wanted to give our users something that they could only experience on VR. We wanted to offer all content in IG in 3D for our Quest users. And stereoscopic media, images and videos, would give us that immersive experience. And we knew that we could leverage AI to do this. But what does it take to build a stereoscopic image? What is a stereoscopic image? It's basically an image that creates the illusion of 3D. By presenting a slightly different version of the image to the left and the right eye, we trick the brain into seeing 3D. Basically, we shift pixels around based on the depth of the content of the image. Remember the 3D movies with the color glasses? It's the same principle. And how do we create one? How do we generate a stereoscopic image? We take the original 2D image. We run it through a model to estimate the depth of each pixel. These are called monocular depth estimation models. This generates a depth map that then we use to shift pixels around and in-paint the missing parts in the image. After we have this, we put both sides of the image together, we encode them into a single file. This is not a new concept. The stereoscopic images and videos have been around for a while. There's many models in the market that vary in quality and speed. And they have been used in many applications, like 3D model reconstruction, autonomous cars, for example. But we wanted a model that was high quality and that could work in real time. So we created the meta-depth model. But what does it take to take this model and make it work at IG scale? I want to talk about some of these challenges, the IG scale challenges, the latency requirements that we faced, the quality considerations, and then finally some learnings and future work that we're taking on. As you know, Instagram has millions of users, it's a very, very big user base. Millions of pieces of content get uploaded every day, and all kinds of formats. They have different sizes, different kinds of media, images, videos, text. But only a small subset of that media ever gets displayed on Quest. So how do we make that all content in Quest is in 3D? This is the challenge that we faced. Let's take a look at some of the decisions that we had to take. The first problem was when to convert. We could do it at creation time, when the user posts a story or a piece of media to Instagram. At that point, we would have more time to convert it. But the big problem is, we don't know if that specific post is going to end up on Quest or not. So to achieve our vision of showing all content in 3D in Quest, we would have to convert everything that gets uploaded in Instagram into 3D. And as you can imagine, that takes a lot of compute power. And most importantly, most of the conversions would be wasted, because most of the conversions would never end up displayed on Quest. The other option that we had is to convert at consumption time, when the user actually consumes the media. At that point, it will be guaranteed that we only convert the things that are going to be consumed. We don't have any wasted conversions. But it still requires some power to convert, because there's a lot of media that still displays on Quest. and it's very, very latency sensitive. We would have to convert very, very fast. Users usually spend a few seconds on a post and are not willing to wait for minutes to convert a video into 3D. So how do we make our pipeline really, really fast? That was the problem. The next question was where to convert. Again, we had two options. One was we convert on the headset. We use the headset hardware to convert the video. In there, everything is local. We don't have overhead to talk to servers. Everything is more or less simple. But the headset still requires some GPU and some CPU capacity. And the headset has limited capacity and limited hardware that has to be shared across different applications and the OS. So the other option would be to convert on the server. In there, we could take advantage of caching for shared posts. We would be able to use more computing power for better quality and more flexibility. And it still requires a fair amount of GPU. In the end, we decided to go at consumption time, when the user requests the post and sees the post on Quest, and convert on the server to take advantage of the better quality and more flexibility. But how do we make it fast? Which brings us to our next problem. Initial benchmarks showed that we were taking about 200 seconds for a 20-second reel. That was obviously too slow. That maybe work for images, but not for videos. So what did we do? Our initial naive approach was take a video, extract the first frame, save it, then send it to the GPU for processing, for depth estimation processing, save the result, then run the post-processing, warping, and in-painting algorithms, save it, and then run all frames in the video like this. Once all the frames were completed, we would encode everything together and write the final MPEG file. As you can imagine, this was very slow. So what did we do to make it faster? We basically took 3 strategies to make it faster. One was parallelization of all the process. Next, we do a lot of code optimization and tuning. And finally, we want to get ahead of the user as much as possible in terms of the conversion. Our target was to be able to convert a 20-second reel in less than 15 seconds. To parallelize the flow, basically what we did was we took the original video, we split the video in different chunks of frames, then we sent each chunk to a different GPU, and we took advantage of however many GPUs were available on a given host. And GPUs would process depth estimation and in-painting. And once all the chunks were completed, we would put everything together and progressively encode the final MPEG file. Additionally, to split the work, this helped with reducing the movement of data from CPU to GPU and back. Also, we work on a lot of code optimizations and tuning. We quantize the model to reduce to a smaller floating point values, and these didn't reduce any of the quality of the output. We also tested a lot of different batch sizes and different forms of optimizing and parallelizing. And we spend a lot of time tuning the encoder parameters to get the best possible performance without compromising any of the quality. Finally, we wanted to get as ahead of the user as much as possible. We wanted to trigger the conversions as early as possible. As soon as we knew a post or a video would be delivered to the user, we started the conversion. That gave us about 2 seconds of lead time before we actually had to deliver the video. From the app, we also requested videos in batches. We requested the next 10 videos and so on. So we would have some videos always ready to be played to the user. And we tuned a lot the timing and how the scrolling behavior happens. So we will always have videos ready for the user to play it as he was scrolling through the feed. All this work paid off. Right now, we're able to convert videos faster than real time. Most videos are converted in less than 10 seconds, which enable us to give our users the immersiveness and convert all the media in 3D that we were aiming for. But what about quality? We took 3 different approaches for quality into consideration. The first one, comfort. If you remember the original 3D movies, and if you saw some of the original 3D movies, it was hard to look at them for like long periods of time. That's comfort. So we were worried that we needed to do a lot to make sure that the user had a good experience. Next, the depth feeling, or how much depthness we offer to the users and how much depthness we introduce into the videos and images. And finally, the quality of the media, of the resulting media. As you know, IG has many different types of content. Videos, images, text, now AI-generated videos. And the users are scrolling through their feed, they're jumping from one place to the other, they're commenting. And we wanted to ensure that the users have a comfortable experience throughout this time. We know that 3D can be tiresome to look at for long periods of time. It can cause nausea on some people, and we were worried that having all these multiple types of media would cause discomfort to the users. So we adopted a top quality principle. Do not make users feel discomfort. And we drove all quality decisions based on that. Comfort is also related to something called convergence point. When the object that you're looking at appears to be in front of the user, in front of the screen, we call that negative parallax. This is when the convergence point is in front of the projection plane. This gives you a very impressive 3D effect. Things jump at you out of the screen, and it's very, very big wow factor. But it's also tiresome to look at for long periods of time. So we tried other approaches. Zero parallax is when the projection plane, the convergence point is at the projection plane. This is better in terms of comfort, but still has some problems, some window violations, and some discomfort. And finally, positive parallax is when the convergence point is behind the projection plane. It's as if you were looking through a window into a 3D world. And although this has the least wow effect and the least 3D-ness, it is the best option for comfort. So we went with positive parallax. Another big problem that we faced was text. IG content tends to have a lot of text. Posts have stickers, text added to them, and that text is not physically part of the image. And that presents a problem for the model estimation, for the depth estimation models. The models think that the text is part of the image, and they make it follow the contour of the image, given for a very unrealistic scenarios. So we created a new model that detects text on the posts, and then we apply that to extract the text and put it in front of everything else in the image. And this mostly fixes our problem with text. To summarize, we developed a new depth estimation model. We took it from 2 minutes to 10 seconds. We integrated a pipeline to handle all of Quest IG traffic. And we finally gave our users the immersiveness that we were looking for. So what are some of the learnings that we take from this experience? Normally, in any AI-related project, you're trading off latency, quality, and compute power. In our case, we needed to find alternatives to our latency requirements and be very clever of when and where we converted the videos. Also, always optimize for the users. For us, it was a trade-off of the wow treatiness factor versus long-term comfort of the user. Finally, let's take a look at some of the challenges we're looking at the future and we're working on. We want to make our Instagram even more immersive. We want to make it so you can walk into a post and really experience what was to live in that post. And as you can imagine, once we do that, we need to make everything faster. Everything has to be a lot faster to make it realistic. Really appreciate your time, and if you're interested in this space, I would love to talk to you. Thank you so much. And I think we have some time for questions.
And we do have a question from the audience. An audience member asks, will this same process work for long-form movies?
That's a great question. The same principle works for long content, although our pipelines are optimized for IG content specific. So to make it work in real time for long movies, for more than 30 seconds or 60 seconds, which is IG content, it'll take a lot more architecting and try to figure out how to make this work in a long form.
Okay, thank you for that answer. And that's all the time we have for questions right now. If we could get one more round of applause for the presenter.
Thank you very much.
Please welcome to the stage Jessica Powell from AudioShake.
Hi. Humans and machines both have hearing problems. Humans excel at understanding real world, physical world sound, but we can't edit and filter sound like machines. On the other hand, machines struggle with that same kind of sound and some of the human level nuance that goes into our communication. So imagine we all went into a bar right now. We probably wouldn't enjoy having to yell at each other over the crowd, but we could probably understand each other. Take a machine into that same environment, say like a transcription engine, and you're going to have all kinds of problems. And so this is what we do at AudioShake. We make sound usable for both humans and machines through audio separation, or something called source separation. And that's where we split sound into its component parts. And I'm Jessica Powell, the CEO and co-founder of AudioShake, and thanks for having me here today. Thanks. What we do is we take audio that sounds like this. And we can extract and isolate what matters.
And the liftoff of the Space Shuttle Discovery returning to the space station.
So you could almost think of it as not simply separating the signal from the noise, as people like to say, but separating the signal from the signal, or more precisely, separating the desired signal from the undesired signal. So let me show you how this works. So sound isn't easy for a machine to understand. What you see here is the audio spectrogram, so the image of an audio file. And we have frequency on the y-axis and time on the x-axis. We have some sense of amplitude or loudness, but that's about it. We don't know, looking at this, is this a conversation? Is it a piece of music? Is it a film? So what we do at AudioShake is, and actually, let me talk about the problems then. So some of the challenges in doing source separation are, first of all, you have a lot of overlap in frequency. So a piano can sound like a guitar. One man's voice can sound like another man's voice. A second problem you have is unknown mixing process. So you don't know what environment this recording was made. Is it from the 1950s? Is it from yesterday? Is it a busy street corner that's being recorded? Or is it actually in a recording studio? And then if it was a recording studio, what was the room tone, the acoustics of that room? So all of those unknowns can introduce extra information. Finally, different sounds have different characteristics, and that can require different model architectures or different Fourier transforms. So different sounds you might want to, in order to retain the snappiness or different contours of that sound, you can't use like a one-size-fits-all approach. So what we do at AudioShake is first we identify what this sound is, and we're working on the spectrogram. We essentially color in these different sounds. And then what we're going to do is we're going to black out or silence all the pixels that don't correspond to what we're searching for, what we're targeting. In this case, we're targeting a specific speaker's voice. And then that just leaves behind speaker one. So this isn't generative AI. Again, it's a different area of deep learning. It's known as source separation. Now, there's a big challenge that you come into when you're doing this if you want to make these models fast, simply from a cost perspective or because you want to enable lower latency workflows. So the first problem, and this is applicable to a lot of AI, is that bigger models outperform smaller models on quality. Second, the models benefit from more time context. The more you're feeding into the model, the more information it has, the better the quality is going to be. The smaller the chunk, the less context for separation. So you're always in this dance between how fast, how lightweight you can make these models and still keep them really high quality on the output side. And finally, if you want to do lower latency, you want to have streaming applications, you want to run on device, well, edge devices normally only support a subset of the operations or only perform it on a subset of the operations. So what you do for iOS and Neural Engine doesn't work when you turn your attention to Android. And none of those things really work when all of a sudden you're then trying to tackle low-end devices too. But this is what we do at AudioShake, is we focus on that intersection of performance and quality. And because of that focus, we're able to significantly outperform open source in that area. So if you just looked, for example, at our vocal model, we're several orders of magnitude better on the quality score, which is called the SDR. And also on the performance side, we're able to have a much, much faster model. That then enables us to deploy in all kinds of different ways, for example, running on edge devices. So once you can do this, get the quality and the performance, you can enable all kinds of applications from the most kind of human, creative editing workflows through to at-scale machine workflows. So let's start with the humans. With music, if you can separate a music track, for example, you can power all kinds of really cool editing tasks. Remixing, sync licensing, remastering. The first two pictures you see here are of two iconic artists, De La Soul and Nina Simone. And in both of those cases, what we were doing is working with those labels and estates to separate their tracks so that they could make an immersive mix. Any of you that are working in VR know a ton about immersive audio, and one of the things in VR is, audio, you want it to feel like real-world audio. And real-world audio isn't coming at us just like this, like it is when we put on our headphones. It's all around us. And so you want to create that spatial or surround sound kind of effect. But what do you do if all you have is a single track recording? Well, you use source separation to split it up, and then you can put the sound objects in different perceptual fields. So the guitar could be here, the vocals could be here. And so that's what we did on those. On the real-time side, we're in applications like DJ Pro that allow you to DJ in real time. On the film side, one of the very first things that we ever worked on was the iconic Doctor Who, the TV show. And all that we had was the dialogue, the music, the effects, and even the director's commentary, all on a single track. And because we could separate those, that allowed a German production company to retain all the rich background audio of Doctor Who, all of the sci-fi effects from the era that it was recorded in, and overlay a German dub on top. In broadcast, there's lots of kinds of scenarios where you are, say, a newscaster is at a construction site or some place where you want all that background, right? There's a reason the newscaster is choosing to film there. But you may not want it to overpower what the newscaster is saying. So if you can, in real time, boost or lower specific sounds, separating, say, the voice from the background, you have a lot more control over the audio. And maybe something that's a little unexpected is thinking about this from a compliance perspective. So if you're working in UGC, or if you're a company or brand, a lot of times music can get caught in the background of your clips that you're posting to social. And that can cause big copyright fines. But if you could come in and keep the dialogue, keep the effects, all the natural sounds, say the squeaks of the sneakers on the basketball court and the speech, but disappear all the music that's going to cost you huge fines, that allows you to go ahead and publish that clip. So let me take you through a really quick demo of some of these uses in practice, and then we can talk a little bit about how this actually gets orchestrated.
I've been feeling kinda down a lot. Yeah, I stare at the ceiling, but there's nothing there. I got the feeling, won't you come with me to a higher place so we can.
It's like a dream come true, isn't it, really?
We talked about nerves and coming into a game like this, just the magnitude of this game, massive game. Was there a hangover at all from last season, the result and the coming to a stadium?
Everything I do is financed by me, so you're not the words contributed. Just like my salary is contributed, but nobody ever mentions that. Sir, you're gonna add another level.
Couldn't be more mistaken. We're here to help you.
By deactivating them.
Absolut, ja. Dort hat sich was eingenistet, Noah.
I think that you should get an airport. No, I think that you should get to an airport like 30 minutes before boarding maximum. I want to walk right through security.
You enjoy it, you lounge. That's why it's called a lounge.
Nice to rearrange. Until the music's through, I just love the way.
So let's look at actually how this works in practice. If we were looking at that copyright example where it was America's Funniest Home Videos, that music license had lapsed, and what they needed to do was be able to remove that music and replace it with new music that they now had a license for. So you have the media file come in, AudioShake is going to detect the music even in a really, really noisy environment. That film, particular one, wasn't super noisy, but think of like a crowd, like a sports stadium, right? That can be really, really hard. You've got a lot of crowd noise, a lot of commentator, a lot of sound. We're going to detect that music, then we're going to isolate it. So we're going to extract the music. We're going to run rights recognition against it. And then the client can see, is it music that they own or is it third-party music? If it's music that they own, say in their CMS, they're just going to write the rule that it's going to publish the clip as is. If it's third-party music, they're going to swap that with the AudioShake edited version and publish that version instead. So now let's talk about the machines. So anyone working on voice knows how hard noisy environments are. I gave that example earlier of the bar, or you saw the rocket lift off. Those are kinds of places where technologies like ASR, transcription, captioning, voice AI really, really struggle. Not clean environments like this where it's generally really good now. But if you can isolate the voice before it goes through the workflows, you see pretty significant boosts in accuracy because you're putting a clean input. Basically, you're putting in an input like this would be right now into the system. And again, if we were thinking about how that gets orchestrated, you have your file, you're going to separate the speech, and if you want the background, you can keep that too, the music, the effects, whatever it might be. You're then going to take that isolated voice, and you're going to run it through the next step of the workflow. That might be something like ASR and captioning. It might be voice AI and some sort of dubbing, like a synthetic voice that you're putting on top of it. And if you were doing dubbing, much like that Doctor Who example that I showed, that was a human dub. But in either case, whether it's a human dub or a synthetic voice, you can take that and then stitch it together with the music and effects that you've isolated. And you now have a localized file that's very faithful to the original version, and you're giving a much better experience to the foreign language viewer versus what we used to do, which is simply dub it, caption it, get rid of all the other sound, and have it sound really, really sterile. Another use is in generative. So if you think about all the generative, like in some of the things that we've seen this morning, right, in generative media, it's wild and super cool, all the things that you can create. But if you take a step back and actually think about how we as humans create, which is like a highly iterative process, whether you're good or bad at it, right? Whether you know how to draw or don't know how to draw, there's still a lot of erasing and changing and moving this thing and moving there. And then if you think about generative today, it's still really primitive, right? A lot of times what we're doing, even though it's getting better, is that we're creating and then we're recreating and recreating and recreating to get the thing that we want. We're doing better and better at prompting, but we don't have as much control once we get something that's almost there. One of the solutions for this, there are obviously many things that have to be solved, but on the audio side, source separation is a really great way to give people more creative control. So if a generative music system was to output something that you generally really liked, but say you didn't want the guitar there and you wanted a ukulele, well, you would just remove the guitar and then you would just be generating a ukulele in its place. And finally, multimodal training. So if the machines are going to help us and live up to all the hype of all the things everyone's telling us AI is going to do for us, then they're going to need to be able to see and hear and communicate like us. And they're still really far off from being able to do that effectively. Lots of things have to happen for that to come to fruition. But one area, when you think about the hearing and the communicating part, is, for example, if we look at speech. An ideal way to try and tackle, say, conversational AI and to be able to communicate like humans would be, of course, to train on millions of hours of human conversation. But when was the last time that you had a conversation with your mother and you walked into a recording studio and she walked into a recording studio and you both cleanly recorded separate speaker-isolated streams of the two of you arguing about the way that she punished you when you were a kid or whatever? Never, probably, right? There's very little data in the world that actually has natural human conversation separated. And so all of the ways that we communicate, that's really, really nuanced. If we were having a conversation right now, you would be saying, uh-huh, and yeah, and maybe laughing, or all kinds of filler words. Those are the things that in more scripted conversations, data that we do have separated, doesn't end up in there. So if you can instead take your company data or data that you're licensing and be able to separate it using AudioShake, you're now able to train conversational models that actually sound like humans. And I think this is one of the things that's really, really exciting when you go out today for lunch, which I'm keeping you from at the moment, you know, and you hear like the plates clattering and the drinks and everyone's around you talking and so forth. Know that this is an area where we still far excel compared to the machines. And if we're going to have machines that actually help us in a whole range of tasks that we would love to outsource to them, we're going to have to do a lot better job of teaching them to hear like humans do. And I'm excited that AudioShake gets to play a small part in that. Thank you.
And we have a couple of questions from the audience. So you mentioned speaker separation for training multimodal models. What are other kinds of separation that might be useful for multimodal?
I mean, I would say anything, if you're training, say, a generative music model, same thing. You're going to want to train a large amount of music. You're going to have much better results if you can train at what we would call the music stem, the different component level versus just the full track. Similarly, if you were doing video, right? Video, for example, there are lots of companies that are now licensing loads and loads and loads of video data. But that video data has a lot of noise in it, has a lot of speakers talking over each other, because again, they're natural conversations. It also has a problem of third-party music being caught in the background. And finally, it's single track audio. So the dialogue, the music, the effects are all on a single track. And again, if you want to have a more granular understanding of why is this effect coming in at this particular moment in a scene? Why is this happening in relation to, when you're thinking about all the things you're doing on the vision side and you want to understand what's happening on the vision side in relation to the audio side, the more granular you can get across every aspect of that, the better you're going, like the more likely you are to get that kind of human level understanding.
And then we have one more question. Can generative models perform source separation? And could they eventually generalize to do this task?
Yeah, I mean, they can. A lot of the generative systems will have, you know, if you like think on I've seen like music systems that will have stem separation. as part of the output. The challenge is that those models are really good at generalizing, not as good at specific tasks, one. Two, you could imagine, I can think of instances where generative could be really compelling on the stem separation side. For example, it might be better at predicting certain moments where speakers are talking over each other, and maybe could even fill in when you fail at the source, like the separation task. At the same time, generative is a fundamentally different approach, right, from source separation. Source separation you saw on the spectrogram, right? But what we're doing is subtractive, right? We can screw up, we can confuse speaker one, speaker two, we could confuse an effect for the music, but we're not introducing any new information, right? So you can have artifacts in that audio output. I'd like to say that we never do, but it happens. But you're not going to have new information. And I think that actually is, depending on the workflow, that becomes really crucial. Certainly in terms of getting the best quality results, probably source separation, but I think also anything where truth matters. Think of like forensics, right? Like I wouldn't want to be the person that writes the model that has a generative element in it that ends up with someone being wrongly convicted because something got filled in that audio that shouldn't be there. And that's maybe an extreme dystopian thing that I'm imagining right there, but I think forensics, I can think of archival recordings, things like that, where I think you do have to be really, really careful about what techniques you use to make sure that you're not inventing anything. But there's lots of use cases where it's useful. So it's probably a combination of the two in some future state.
Thank you for those answers.
Thank you.
And right now, that's all the time we have for questions. A round of applause.
Please welcome to the stage Ming Shao and Ram Rathnam from Meta.
Hey Meta, tell me about this architecture.
The architecture is a mix of modern and postmodern styles with a focus on sleek lines and geometric shapes.
You just witnessed a simple use case of Meta AI glasses supporting users with ease and independence. There is a lot that happens to process such a request across our devices and servers. Today, we are going to take a deep dive into how we build a privacy infrastructure solution that scales to the needs of Meta AI glasses. Hi, my name is Ram Rathnam. I'm a technical program manager in Reality Labs Trust team. With me, I have Ming, who will be coming later on. Thank you all for joining us today to discuss the exciting topic of privacy in the world of Gen AI. Over the past 5 to 10 years, data handling has evolved immensely due to the privacy requirements, user expectations, and technology advancements. Strong privacy is a table stake requirement for our 4 billion users, regulators globally, and society at large. The solution is to ensure we have an engineering practices that align with our privacy policies and data use commitments. Before I dive into the details, I wanted to give a quick overview of the wearables product line and the unique privacy challenges that we face. From the rollout of Oculus Go a few years back to the most recent Meta AI glasses, such as the Ray-Ban Meta display that we announced at the last month Connect event, the innovation and the pace of change has been breathtaking. With this rapid evolution, we have fundamentally shifted how we handle and provide privacy protection for our users. Meta AI glasses integrate wearable technology with Gen AI to deliver a near real-time information that is not only personalized, but contextualized. Real-time understanding with advanced cameras and sensors enable the users to ask some questions and get an instant response that is relevant to the scene that they are looking at. The contextual overlays and summaries enabled by our generative model AI, offers guidance and information to the user's current location or the activity that they are performing for a richer experience. The natural and intuitive interactions enabled by advanced input technologies such as EMG, as well as the output technologies such as Ray-Ban Meta Display, enables us to provide a very immersive and seamless experience for the users. This highlights that the Gen AI continues to require sensor inputs, near real-time information processing, and a feedback loop to the users. Throughout this process, we continuously need to meet the data requirements that we have at play in terms of what information that we are collecting from the users, how we are processing that information, and what information that we are retaining for future use. Several driving forces accelerate the need for privacy technology solutions, especially in the Gen AI era. The emergence of new data type, as well as the data growth, has evolved into the unique data management challenges. Our ability to compete and innovate depends on our ability to respond to the evolving requirements. The rapid rate of innovation and the product development life cycles requires a solution that can scale and enforce the privacy controls automatically without the developers having to worry about those controls. In our talk today, we will dive into both the privacy challenges and opportunities that are unique to Meta AI glasses, as well as the infrastructure that we have built that addresses those challenges at scale. Finally, we are going to finish off with some key takeaways. Let us revisit the experience demo we opened with. You may be wondering what unique privacy measures are relevant in that simple interaction. The primary goal of Meta AI glasses is to support the users in their tasks with ease and independence. From a privacy perspective, the user interactions and the data associated with that interactions must be purpose protected. What does it mean? Purpose protection means that the data that is processed only for the stated and specific purposes only. To uphold this principle, we identify the data flows that align with this policy. And only those data flows are approved for further processing. Now that we know the basics of our privacy goals, let's zoom in with a little more details on what is happening with that Meta AI glasses user journey. Our utterance or the chat command to the Meta AI processed by the frame or your glasses itself. Given the complexity of the request, the system determines that this requires a server-side processing. The utterance data, along with the context information, is securely transmitted to our servers in the back end. The server receives this data, does the pre-processing, as well as some basic understanding of that request. The request is then routed through the router, which analyzes the request and converts into a structured query suitable for downstream processing. The downstream processing may include various services, both internal as well as external services, including large language models. Once the response is formulated, that response is sent back to the users securely, completing the loop of that interaction that the user had. With this high-level overview of the user interaction journey and the privacy goals that we have for Meta AI glasses, there are unique privacy solutions that we needed to fulfill. I wanted to give us a quick introduction to the privacy infra solution that we built that ensures continuous adherence to our user privacy commitments as well as the regulatory requirements. Privacy has always been a key priority for us. It's an enabler for our innovation. Over the past 6 years, we have invested heavily in what we call a privacy-aware infrastructure, a world-class privacy engineering platform. We call it simply PI. The PI enforces end-user privacy protections, both speed and accuracy at meta scale. What does this mean? We embed the technology directly into the code base, automating the adherence to these privacy requirements as well as the data commitments that we have. As a result, PI enables trillions of user consent checks hourly, as well as automate the protection of millions of user data. And finally, it allows us to deploy, release thousands of products and features with privacy every month. This robust infrastructure for privacy is not just a policy, but it has to be deeply integrated into our engineering and product development process. With that, let me bring Ming over, who will be covering the details of the privacy infra solution.
All right. Thank you, Ram. My name is Ming. I'm software engineer in Meta's privacy infrastructure team. So Ram just talked about the privacy challenges and the opportunities that come from GenAI era. And he also introduced the use case we wanted to deep dive today, which is the Meta AI glasses user interaction. So I'll want to share our solution from the infra perspective. And I'll start talking about the building blocks of privacy-aware infrastructure and talk about how we apply this framework to the AI glasses journey. And I'll zoom in to a few critical pieces and talk about how we have scaled them across Meta. So let me start by talking about what privacy-aware infrastructure, or PAI, is designed to do. We can think of it as 4 must-haves that we have built right into the core. First one, privacy by design. So we don't just add privacy at the end. We have embedded into product lifecycle so that protections are always part of how features are made. Second is extending the infra capabilities. So we know that GenAI now brings more signals, more modalities, and more sensitive content to us. So that has pushed our infra to handle higher volume of data and more varieties while keeping privacy guarantees first class. The next is automated guardrails. So product teams want to move fast, and they want to make sure privacy control can keep up. So we have built PAI to automate these guardrails so that we can make sure we have a high bar across safety, privacy, and user experience without slowing product teams down. And last, future readiness. We know requirement, technologies, and user expectations are always changing. So we have built PAI to adapt so that we can continuously innovate responsibly at scale while the landscape changes. Now let's go back to the AI glasses journey that Ram just talked about and see where PAI actually fits in. So when a user interacts with the AI glasses, that interaction data hits Meta server. And this is where PAI kicks in. It starts from understand, to discover, to enforce, and finally demonstrate. But before I walk through these phases, I want to call out 3 important areas that we're currently investing in PAI to tackle the new challenges at the GenAI era. First, we're enhancing the observability. For understand and discover phase, we build automated scanning and tagging so that we can identify data at the point of ingestion. We also build lineage tracking to maintain a real-time graph to show how data has been propagated and who's using it. The second area is we're making privacy control more efficient. For the enforce and demonstrate phase, we built policy enforcement APIs so that we can apply constraint as storage, processing, and access layers. We also built automated policy enforcement so that regional and global requirement can be embedded into the workflow directly. And the last area is scalability, which underpins all these phases. As I mentioned earlier, GenAI now brings higher volume of data more modalities, and faster iterations. We have made sure the same PI approach can work across thousands of microservices without sacrificing control. So with that context, let's talk about these 4 phases in more detail. So we have designed these 4 phases as a repeatable playbook that run across the products. It always starts with understanding, knowing where this data is, and tagging them with the right privacy intent. The next step is to discover every data flow, so we know exactly how the data flows. And the third step is to enforce the boundaries. We want to make sure data only flows to the approved users and surface the issues if it ever crosses into unapproved ones. And the last step is to demonstrate compliance by proving it continuously. We build and deploy automated verifiers that keep checking this control hold up over time. Now, this is a pretty comprehensive process, and we don't have time to unpack all of it today. So for today, I will mostly focus on step 2, which is discovering data flows, because this is where everything hinges. We achieve data discovery through building out data lineage, and I'll explain how we build lineage and making sure it can scale across Meta with technologies like Privacy Probe and Privacy Lib, which is a lightweight library that I'll talk about later. And I'll also briefly talk about how we achieve enforcement with policy zones, and how do we do demonstrations with automated verifiers. And that will give you a picture of how we protect AI glasses user data. So with that, let's zoom into data lineage. All right, so you may ask, why focusing on lineage? The answer is simple, because even with privacy by design built in, the reality is Meta systems are massive, and the requirements keep evolving. So we realize with design time control alone is not enough. We also need visibility into how data actually moves. So this is where data lineage comes in. It is designed to capture data when it moves from one system to another during the runtime. But doing this at a meta scale is really challenging, because we're talking about millions of data sets. We're talking about hundreds of systems and many programming languages. So how do we solve this? We have decided to build lineage with 3 key qualities. First, comprehensiveness. We want to make sure we can capture all the flows between systems. And second, accuracy. We want to minimize false positive so that we don't mark safe systems as unsafe. And third is low latency. We want to make sure the signals can be generated quickly enough so that we can support near real-time checks. Now, having a high-quality lineage is very important for us to apply the protection mechanisms, such as policy zones, and we can make sure every flow is checked at runtime. Now, to be able to track user interaction data for AI glasses, we need to be able to follow this data when it moves through different stacks. And this is why we build cross-stack lineage. We start by tracking data at the web tier, capture the flows between the web applications, so we know what has been collected initially and how it's been processed. When that data leaves the web tier, we also track that through, for example, logging, and see how data get persisted into the warehouse. The lineage record over there will show which logger wrote which data warehouse tables. Now, for GenAI inference, we build lineage at the service boundary so that we know which systems build prompt, which checkpoint get accessed, which process get a response. And this is really critical for governing model output. To close the loop, we also link the data warehouse tables into the model training jobs and the checkpoint they produce, so that policy rules like approved purposes only can be checked and enforced also for training data. So by collecting linear signal across all these stacks, this helps us to form this end-to-end picture of how data flows so that we can reason about and act on. All right, so once we connect the lineage across all these stacks, we get this type of complete lineage graph for AI glasses user interaction data. If you want to learn more about this graph, please check out our blogs. For now, I'll just call out a few quick points. First, you notice the graph start from the initial user interaction data that got captured in the web tier. And you can follow the path through logger and see it get into the warehouse tables. And you can also follow the path where you see the inference service get invoked and see what model checkpoint are accessed. The second point is, notice some of the nodes are marked with rectangles, and they represent the assets that actually contain the interaction data, and the others don't. Now, this distinction is important because it tells us exactly which systems are in scope and which aren't. The third point is, notice there's a highlighted zone in the graph that represent the boundary we draw around the system with approved purposes to handle interaction data. And I'll come back to this to talk about how we enforce this boundary in later slides. So now we have lineage covered all the stacks. The next question is, how do we make sure this is comprehensive? Because if we miss any data flow, we cannot achieve full observability. We solve this with 3 key design choices. First, with every read and its resulting write, we let them share a correlation key. We then use this key to stitch the read and write together for both SQL and non-SQL processing, even when the I/O is distributed among the jobs. The second is, we built a lightweight privacy library, which I mentioned earlier, called PrivacyLib. PrivacyLib will log the flows in a consistent format so that it can provide a generic abstraction layer across read, write, and remote calls. It also helps us to initiate and propagate privacy policies. The third point is, with the PrivacyLib built out, we integrated into relevant system and Meta, and we also implemented in multiple languages. And this gives us this broad I/O coverage across web tiers, batch processing, and storage layers. And that's how we ensure lineage is comprehensive. We capture the flow consistently, we log them into the same format, and we wire them across the stack. Now, at this point, we're able to discover all the data flows with comprehensive lineage. Now, this is the second phase I mentioned in the PAI playbook. Now we can move on to the next phases. So lineage tells us exactly which system that handled AI glasses interaction data and the flows between them. Now we can use this information to guide and accelerate the placement of policy zones, which safeguard those systems and flows. If, for example, a warehouse table is ever used for a purpose that's not approved, say training a model, it shouldn't, this will be detected and remediated. We also build a series of verifiers that can keep watching these flows over time, so that new or changing pipelines can be continuously checked against the latest control. So to recap, we move from discovering all the data flows to enforcing the boundary with policy zones, and to continuously demonstrate with verifiers. And that is how we ensure user interaction data from AI glasses stays in approved use at all times. And with that, I'll hand it back to Ram for the takeaways.
Thank you, Ming. So you saw that user interaction journey of Meta AA glasses through our privacy-aware infrastructure. We took the user data, we protected for the purpose. We used the Pi playbook to ensure that the end-to-end is sufficiently protected from a user requirements, data commitments, and the data policies. We identified the data in scope. We identified every data flow that we protected sufficiently and enforced with the boundaries using policy zones and made sure that those protections are effective and continuous with the verifiers. The foundational building block remains the same. Lineage to understand the data and track the flows. Enforcement to make sure that the policy zones and other tools are applied to protect that data. And the verifiers to ensure the continuous compliance is fulfilled. To wrap it up, our approach to privacy is to scale the privacy infra, not just the rules alone. By building the pie into the technical stack, we let the guardrails travel with the code so that the teams, the product teams, can move faster and with confidence. GenAI's rapid evolution requires a scalable privacy infra, such as the one that we have built, that can not only adapt to the privacy requirements, but also scale. Pi provides a consistent and a reusable framework and a playbook that the product teams can use to ensure the data is being withheld to the privacy measures that we needed to have on those data. The scalable lineage makes every important data auditable and observable in near real time. Product teams resulting from this can ship their products confidently and more securely. Thereby, we are automating the controls with instant feedback loops rather than relying on any archaic, manual, ad hoc code reviews. As a follow-up, as Ming said, we have a blog where you can learn more about our privacy-aware infra. With that, thank you. Thank you for joining us today. Right after the lunch, we have some of our experts for a privacy panel. We would love you to join that. And we also have a small 2-question survey. It should take about 15 seconds. We would appreciate if you can fill it to let us know how we are doing it. Okay? Thanks once again. Thank you.
Yeah. Please welcome back to the stage Parisa Zari from Meta.
All right, welcome back. Good afternoon. Did everybody have a nice lunch? Awesome. I see that everyone is still at their tables. Some are still eating. But once you're done eating, or if you're not eating, I'd love to get everybody to come to the front of the room and fill out some of these seats up here. You can maybe get a better view, too, of the speakers. So before we get started, there's another chance for you to scan the QR code, so you can have that available for submitting questions for the afternoon session. You also have the QR code again on your agenda in case you miss this one. Well, now it's time again for the prizes. There's a chance to win Meta Ray-Ban glasses. There's actually 2 chances right now. And the way the game is going to work is that you must be here present in the room in order to claim. Once you claim, please make noise, jump up and down, let me see you. And once you do, you can go to the registration desk in the back and claim your prize. I prefer you do that once there's another break, but I know that you're excited and you may want to go and claim your prize right away. So with that, are you ready for the raffle? All right. Okay, the first one, 363-9415. Do I have this person in the room? One more time, 363-9415. Okay, I'm not seeing anyone. Moving on to the next. 363-9073. 73, yes. 363-9073. Okay. No takers. Okay. 363-9441. Anyone? You know, this is why it pays to stay all the way through the end. Yeah, we have time. All right. Next one. 363-9168. Wow. I know. Yeah, it's like, oh. Next one. 363-9382. No. I brought like a few, so I have like 3 more to go through. Someone's lucky day. 363-9479. Yes, someone. Yay, finally, the lucky winner. Yes. Registration desk should have your gift. All right. Well, I said there are 2 chances to win, so that was one. We still have another one. Hopefully, someone in these 2. 363-9199. Okay. I have 1 more before they have to bring me more. 363-9187. You? Awesome. Good job. Awesome. Well, congrats. Congrats to the winners. Super happy for you. All right. Now that we're done with this, and good thing we didn't have to give more, are you guys ready for the afternoon session? Awesome. To start, we're going to have a panel on privacy and AI, which I think is super exciting. It's hosted by my friend and colleague, Joseph Laria from Meta. And we have panelists from Meta, LinkedIn, and Microsoft. Afterwards, we have a few more talks from Agora Labs, NVIDIA, and Meta. And the wearables panel, that's the one toward the end of the day. Please stick around for that. It's going to be super exciting, especially given if you saw Connect, you'll see what we're dealing with wearables, so that's super exciting. So yeah, enjoy the rest of the day, and I'll be back again. Please welcome to the stage Joseph Laria, Drenna Kusari, Mayank Ahuja, Jonathan Bergeron, and Abhishek Goladi.
So, hello and welcome to Product at Scale and our panel discussion. These panels are an opportunity for a in-depth discussion on how to build large-scale products. And I appreciate everyone who's here in the audience and also watching on the live stream. Today's discussion is going to be a focus on the dynamic environment of privacy risk management and compliance and how this is making companies rethink how they evaluate their governance programs while simultaneously trying to drive product innovation. I can't think of a better set of guests to have with me. And let me introduce them. Starting from my far left, Abhishek, Director of Meta Product Risk Foundation. He and his team are automating Meta's approach to risk compliance and making policy risk engineering efficient as possible for engineers. Jonathan's Director at Meta Core Data and Privacy Infra. He's building products so engineers can do their best work while managing the complex set of global privacy regulations and commitments. Mayank, Director of Privacy Engineering at LinkedIn. He and his team are building a scalable, centralized privacy platform from the ground up, enabling consistent enforcement of data policies across all of LinkedIn's data ecosystem. And Drenna, Vice President of Office Product Group at Microsoft. She leads product engineering teams focusing on the critical foundation of privacy, responsible AI, security, along with product growth, empowering teams to innovate with risk compliance in mind. As you see from these bios, there's a lot we can learn from these people. So let's just jump right in. Abhishek, I want you to help me set the stage. Over the past 5 to 10 years, we've seen changes across multiple facets, such as technology innovations in AI, the customer demands, and the rapidly evolving regulatory landscape. All of this has driven companies to reevaluate how they approach privacy and risk. Can you first start defining what is today's baseline expectations for risk management and innovation, and also tell us what this looks like at Meta?
Yeah, thanks for having me, Joseph. I think one of the first things that we should probably think about is as Meta, when we think about regulatory complexity, our initial approach was as all things Meta, just how do we solve this with technology, right? And a little bit of a history lesson is probably important here to set additional context. If you go back to 2020, can't believe it's almost 5 years ago now, at that time, we decided that we needed to essentially rip the privacy program down to the studs and rebuild it. And when we rebuilt it, I think one of the key things we looked for was how do we build excellent processes in place? How do we hire the right expertise while building the program? And also how do we deploy as much tech as we can to automate things? I think this started paying dividends almost immediately, but there were a ton of lessons learned over the last few years, right? And we sort of baked that into how the program runs today. I think one of the key facets that is probably worth highlighting here is how do we learn from the standard things that we're doing on a day-to-day basis and make sure the program essentially evolves to keep up with risks that are also moving at pace, right? And I think there are a couple of key concepts here to ground us in. One is the idea, in practice, you realize that a lot of the risks that the teams are facing as they're trying to ship quickly are very standard. These are things how do you respect deletion requirements, for example, right? We don't want every product team trying to go and reason about these requirements from scratch. So the idea was how do we make sure that these things are standard, available to everybody in a playbook that doesn't require us to essentially rebuild things from scratch. I think the other key component of the program was what we think of as key controls. And these are standard implementations at the code and infrastructure level as guardrails to make sure that once product teams decide to comply with the requirement, that we know they're abiding by it and they're doing it on a continuous basis. I think what all of this meant was because we were taking sort of the standard stuff off the table for teams, the experts in risk could really focus on the novel risks as much as possible and spend their time focusing on those areas, leaving the rest of the machine to really run itself. I think these are the key facets that I think are baseline requirements, great tech, expertise and human judgment at the right time, and really like marrying all of this with great processes.
Okay. Trina, let me ask you the same question. What's Microsoft's approach to innovation while at the same time managing privacy, risk, and safety?
Yeah, thank you. And thanks for having me. It's great to be back on this campus. Look, the thing that in many ways also pulled me to Microsoft is that Microsoft runs on trust. The trust that we have with our customers, whether they're large enterprises or really consumers, is sort of the biggest asset that we have, and we protect it dearly. And so, when we think about how we approach privacy, security, responsible AI, it's really at the foundational layer. It's the foundational elements that are embedded early in the engineering cycle. Those can look like a few different things. First, automated checks, code scanning, policy enforcement, and integrated into developer workflows. If you think about these elements, really sort of highlight the shift left approach that we not just sort of execute on, but really it's super foundational. So we think of everything from RAI by design, privacy by design, and it really creates this culture in many ways in terms of just the way people do their work. We also use, if we're getting a little bit tactical, layer defenses. So think, upfront threat modeling, red teaming, platform guardrails, which we also take quite seriously, runtime monitoring, with a lot of human oversight as well. So, in many ways, I think these frameworks and these processes and practices really enable us to make this sort of an early and foundational way of how we do our work. In many ways, it also doesn't create this environment where you're constantly trading, innovation for compliance, or making it feel like, teams feel like this is a burden, a thing that we have to do, because it is built in early into our, software lifetime cycle. It just really creates no friction, or it at least removes a lot of the friction from the process.
All right, thank you for that. So, Mayank, what approach is LinkedIn taking for risk management?
Yep. I think very much on the same line. I think at least everyone on the stage would agree that privacy and security are no longer the bolt-ons of the development cycle. It has now become a core design principle while developing any software, to the extent that all infrastructure should actually be enforcing all of these policies right from the beginning. So at LinkedIn, our aim is right from the beginning, from data collection, even the creation of a single data set, the usage of that data, and the whole life cycle, even to the deletion of that data. We want to follow these principles where the risk is actually looked at. We follow the principles of shift left. We follow the principles of privacy by design. The other part which is also critical is we have to keep pace with the regulations, and they are evolving at a much faster pace, which probably means that developers cannot go back every time and reevaluate their compliance solutions. So you need some programmatic approaches. Mm-hmm. That's another paradigm which we are bringing in to enforce all of these policies automatically without product having to go back and retinker everything together.
Okay. So we've established a baseline for the rest of this discussion with these foundational topics. So my takeaway so far is that we need to reimagine the approach to privacy and risk, instead to reposition it as a competitive advantage, as opposed to just like a checkbox of things that we need to do. So I want to circle back onto my colleagues at Meta to discuss the competitive aspect a bit more. So it seems to come down to how AI is used to kind of drive advantages. Abhishek, coming back to you again. What role do you see AI playing in the evolution of risk management that's going to accelerate product innovation?
Yeah, I think, look, it's hard to escape AI these days, right? Like it's everywhere. So if you think about at the top of the funnel, we totally expect that AI is going to dramatically increase engineering and product productivity and velocity, right? And I think the number of things that are coming to risk systems and risk experts to be assessed, to be adjudicated on, that's going to start scaling super linearly as well as AI makes the top of the funnel like incredibly productive. I think if we just do not evolve the processes that we have in risk and compliance to essentially like evolve in kind, we are going to absolutely find ourselves like inundated and overrun as a program. So I think one of the key things to think through here is like all of us probably share a risk review process, right? That is essentially meant to look at new changes being designed and discussed by product teams as early as possible rather than asking teams to fill out a form like the day before they have to launch a new product, right? I think the key is to like generate as much context as we can ahead of time. Just to give you a sense of scale, on a monthly basis, we look at approximately 1,400 new requests for features, et cetera, that are going through all of Meta's products pipelines, right? You just cannot keep up with this level of scale unless you automate and use AI in a lot of places. So it's all about, rather than asking teams to fill out forms, like, can you just upload your product spec, and we should be able to extract a lot of the information that we need to risk assess and figure out what standard requirements apply to you, mostly automatically, right? So these things are now live. Also, can we essentially offer you diffs while you're trying to land your changes that automatically adopt the controls that I just talked about, rather than asking you to then take another week to like comply with the change or the requirement by writing additional code. Like I think all of these things essentially then allow the experts to essentially focus on the novel risks. And I think this is how a lot of the product innovation, I think Drena had a great point about like we do not want to trade off like innovation for compliance constantly, and this is a way to basically avoid doing that.
Okay, I want to follow up on this comment about guardrails and unpack that a bit. And I want to get Jonathan's thoughts on this. Jonathan, your team owns core data, and you're also responsible for applying AI into the risk program. So I'm sure there are challenges to ensuring the code base is maintains reliable for product launches while supporting a continuously evolving policy landscape. So what guardrails are you establishing to ensure that AI and automation are working the way they should?
Well, first of all, thanks, Joseph, for having me here, and pretty excited to be on stage with you all. Our companies have been working pretty closely together over the years to advance the state of the art for privacy engineering. So I'm pretty delighted to be on stage with you all. As you mentioned, I think earlier, there's a massive number of complex privacy requirements that Meta must meet continuously. And as product engineers, you can't possibly remember all those rules and regulations. So at Meta, over the past several years, we built a platform called PAI, Privacy Aware Infra, that does just that for you. It's been a project we've done for years now that creates transparency in our data, in our system, and how the data move across those systems. And we also offer possibility to create verifiable safeguards and controls to meet some of the most complex privacy requirements. And we have an entire series of engineering blog posts about it. If you want to check it out, the keywords is purpose limitation at Meta.
Nice blog.
But essentially, PAI is the infra foundation of the risk management program and system that Abhishek talked about. At a very high level with PAI, you can create privacy rules that we embed in the code base, and we propagate it all the way down in infra. So it's durable. So product teams can focus on innovating, essentially. So at Meta, when there's a major privacy initiative going on, we can deploy it across the entire code base almost seamlessly so that you product developers can focus on building products instead of being privacy experts, because we automate all that for you. In areas where we don't automate all, when we need human in the loop, we use AI to actually accelerate your work. So for example, we'll use AI to create annotation for your data, for example, and suggest it. Or we will use AI to generate massive code changes if you want to deploy a commitment across the code base. So all these things are in place so that we can really maximize your velocity as developers, but do it in a safe manner.
So Drena, How is your team at Microsoft addressing this point?
Yeah, it's a great question. For us, guardrails also a critical sort of strategy and approach. And as I mentioned before, it's a bit of a layered, defense strategy. Starting with robust input validation, prompt filtering to mitigate risks like, prompt injection, excessive model agency, which we see often. These technical safeguards are complemented with continuous monitoring of model outputs, automated detection of suspicious patterns, and then regular audits done by our teams, to ensure that the systems behave as needed and as expected. We also really prioritize things like runtime observability and feedback, feedback loop, to generate, the right sort of platform and ability for our engineering teams to quickly identify and respond to such risks and such flags that show up. Yeah, this is especially important, as we all know, with large language models, where the evolution is happening incredibly rapidly, and with that comes sort of a set of risks that it's hard to contain, and so you have to be super prepared. And going back to my earlier point about shifting left, right, that really helps us almost like get ahead of it. So we take that quite seriously.
All right. So it's been good to hear from everyone on how AI and automation is driving privacy and risk innovation. I want to transition a bit now to talk about what that means for developing new and novel product experiences, those 0 to 1 projects. And I'm excited to dive a little bit deeper here. So I'm going to start again with Drenna at Microsoft. As you mentioned earlier, privacy, risk management are core to what you're doing at Microsoft. In particular, how does responsible AI by design and AI safety look like at Microsoft? And can you share an example of how that works?
Yeah. And I think I've touched upon this now a couple of times, but, for us, we see responsible AI evolving truly from principles to practice, right? Where safety, privacy, trust, and responsible AI are not just aspirational, but really measurable things. We simply wouldn't feel good, right, if that wasn't the case. But we are investing in a number of scalable, systems, starting with evals, since you talked about an example. For us, evals allow us to truly test, AI systems, ensuring that the benchmarks that our product teams establish, are essentially hitting the expectations that we as product makers, but essentially our customers, which is who we're building for, they hit those marks. And, in many ways, they protect against the various adversarial sort of scenarios, including misuse, prompt injection, like I mentioned, and so forth. If we talk specifically about the area where I'm in, for example, in PowerPoint or Excel, we're seeing teams, take a very robust approach to evals. It is, in many ways, how we're accomplishing this. And I know that's, standard practice now when it comes to product teams. But that's a good example for us.
All right, thanks. So a similar question to you, Mayank. What does responsible AI by design look like at LinkedIn?
So let me start from the fact that it's an interesting time. While the privacy engineering practices are changing because of AI adoption, at the same time, AI is changing how privacy engineering practices are created. So it's a bi-directional change which is happening. At LinkedIn, responsible AI, we base that into multiple layers. The foundational part of any AI model or training of the AI models in any of the data access is based on data management. From the fact that you are creating a data, to an accessing a data, to a catalog of the data, to classification of the data, to figure out in what cases what will be used, to the point Jonathan was sharing around the purpose aware infrastructure, those are very critical aspects of the foundations to be ready before responsible AI practices can be put on top of it. Within responsible AI, we are looking at the standard practices like benchmarking, red teaming, stress testing. So essentially, we are forming a closed loop whenever any feature is launched on platform. So we are looking at the safety, we measure how that safety is looking like, and then continuously iterate on those safety measures of those things. So essentially, it's a very layered approach. There is no one answer to the responsible AI part, but I think it starts from the base set of where the data resides to data management practices to higher level practices of responsible AIs on top of it.
Yeah, if I may just add something, for us, we really think of a lot of the elements that you mentioned almost like a flywheel effect. Like you can't just rely on one thing. It has to be multiple components working together, maybe fueling the flywheel, so as to get that level of comfort that we're looking for.
All right, thank you. So now let me circle back to Meta. So Abhishek, I'll start with you, and then Jordan, I'll follow up with you. Abhishek, as I understand, you guys have enabled some new risk management products for your team, and they're enabled by AI with automation. Can you expand on that work a bit?
Yeah, one of the things that we're super excited about right now is, look, a classic sort of risk management program is obviously geared towards making sure there's sufficient oversight and monitoring built in so that like the things we expect to be happening, we make sure that they are happening, right? But obviously like doing that in a brute force way is not going to scale, right? So we realized we were collecting all this data about like SEVs happening, which is like some like fault in the system that happens. We do a full root cause analysis. That we have all these privacy policies and risk policies now like in a mature state. It was like, how do we actually go beyond just like, standard testing? So like one of the ideas was like, can we take all this data and then simulate proximal faults that are not the exact fault that we saw, like, because we'll obviously mitigate the thing we saw that failed last week, but like, how do we essentially generate a suite of tests that are like slightly off, but generated by a machine learning model? So now what we started doing is we essentially started feeding all this data, started generating a bunch of unit tests across the code base. So we call this automated compliance hardening because you're really hardening the code base, not just from the faults that you know, but all the similar fault types. This obviously started picking up steam. We started essentially applying this at scale at meta scale. But then we said, why not go a little bit further? Why not, while you're trying to ship code and land code, at that time, can we detect is there a privacy fault in your code? And the gold standard isn't just to tell you that hey, I think something might be wrong here. Can you take a look? I think it's much more if you've tried to land code, a failing unit test is sort of the gold standard for hey, I need to fix something here, right? And so what we've started seeing now is LLMs being able to generate very targeted but failing unit tests to point out the exact fault that your code has so you can fix it before the code lands.
That's right.
And now we are averaging close to 1 to 2 SEVs prevented each week. And we've just published a blog post on this and published some research as well. So I encourage you guys to take a look at it. But that's one example of actually keeping up with the times with AI.
Jonathan?
Yeah, so we just did a presentation on how we use PI novel ways to help protect GenAI features. You guys can check it out. We also have a blog post that just came out today about it if you want to check it out. And I do agree, the importance of emphasis on talking about the benefits of using AI for the risk space. There are many examples, such examples upstream, like Abhishek mentioned. There are also the example when we say roll out major privacy initiative across the company. There's huge amount of very complex stack traces that we have to analyze. Massive amount of code we have to review. And models are obviously extremely good at this compared to humans. So we use it to accelerate our work and minimize our mistakes. In fact, a lot of this work would not really be practical if we didn't use AI to do it and assist our privacy experts, essentially. Having said that, when we introduce new technology like this in GenAI, we introduce new product decisions to be made. And these decisions needs to be made by experts, judge. And this is part of the risk management program that Abhishek highlighted earlier, and the risk flywheel, when we have novel risk, introduce new requirements, requiring us to evolve our technologies, essentially.
All right, thanks, Jonathan. This is a great segue into my final topic today. We've looked at some key aspects of AI and automation technologies that streamline risk management and how to create those trusted product experience. So now I really want to kind of look forward to see what's coming next. So given that AI is moving fast and it's evolving, it's changing even today, I want to understand like how product teams have to face these new types of product decisions that come up because of AI. So Abhishek, first, can you tell me about the expert-led approach and how you think this is actually provides greater consistency of data compared to a purely AI system?
Yeah, I think that's a hot topic right now, and I think a very important one. I think building automated and AI-powered risk systems, if anything, allows the human judgment and the expertise in risk management to really shine, right? And the way we see it play out is because we're taking a lot of the cognitive overhead from the system for standard requirements, because they're automated now, the systems are able to actually highlight and point out when we detect novel risk, right? And with the advent of AI, like in our products, like that novel risk is obviously going to go up, right? Where we have to reason about new classes of risk that we need to manage. So I think that's where we see a lot of the consistency play out. So not only do we want to standardize the things that are established risks and how do we mitigate those risks, we also want to make sure that the systems are smart enough to know their limitations so they can actually call on the human expert at the right time, right? And that's an important concept, and we are working through it. And the other piece that I think is the flywheel concept is super important. Once you detect that there's novel risk and a bunch of human experts actually then come up with ways of mitigating that risk and managing it, we want to make sure those learnings feed back into the system so that the next time we detect something similar, we are not sort of reinventing the wheel, so to say. So we can actually rely on that judgment that's already been codified into the system, so make sure that things move faster the next time.
Okay. Trina, what are your next steps to scaling safety with AI?
Yeah, I mean, a lot of what Abhishek has said, the way we think about scaling, it's really about building it inside the infrastructure, not just the governance piece. So this means building system that makes safety, and compliance part of the default engineering, systems, process, and practice. I mentioned a few different examples, previously around red teaming and so forth. But for us, the experience has to be so deeply embedded into the process that it almost feels, natural, right? We really don't want to do rework. We do not want to, the product teams and engineering teams to have to deal with this later in the life cycle. And so for us, we're really thinking about, how do we move this front and center and make it truly a part of how we do. Going back to just the principles, right? And I started my first maybe answer, but Microsoft runs on trust, right? We do not trade innovation for velocity, but velocity is really important. And so being able to really build this in our product making is just absolutely critical. And so that comes through in our tooling, in our processes, practices, in our review processes as well. We talk a lot about how do we accelerate, how can we enable and maybe almost unlock product teams so as, this doesn't become, a thing that they have to do. So really, really designing with our product makers in mind.
Okay. So, and for you, Mayak?
Yeah. So, where we have seen is AI works pretty well with when there is a lot of data involved, there is a decision making on those things. We have gotten a lot of success with things like data classification, even implementing some of the monitoring of these things and even detecting some of those violations automatically. I think I still feel AI has not yet in a state where it can understand the nuances of regulations, for example. What's the right consent, and also like in sometimes on whether this is a legitimate difference versus it's a discrimination kind of thing. So an expert in the loop is needed for taking those right decisions. There are these tricky things which we have seen when we have built in a lot of automation. Is one of those things is automation bias. If my work is getting reduced from days to seconds, will I think a lot if I get a notification of OK or cancel? Maybe not. You know, like, but it can lead to some other violations and other consequences of those things. And similarly, there are things like agency limitation. If everything is automated, are we challenging that system enough or not? Yeah. So I think we are seeing some of those trade-offs, which the systems will have to evolve and will have to put those options in a different manner to the end users. So I feel it's going to be a combination of the two, where we use the power of AI for driving automation, making analysis, but at the same point of time, the human will be in the loop to have the governance solution around it.
All right, thank you. All right, so we've come to the end of our talk, and I know I've been enlightened. I want to thank our panelists, Abhishek, Jonathan, Mayak, and Andrena, for this really engaging and thoughtful discussion. We've heard from everybody here about how companies are working to harness the power of AI and automation to manage compliance and risk management efficiently to accelerate product innovation. These approaches ultimately deliver faster, safer, more trusted experiences for the user, and that's the intent. And finally, I also want to thank our audience for listening to us and accepting what we want to share with you, and for those watching on the live stream. So please, everyone, join me in giving our panelists a round of applause and enjoy the rest of Product at Scale.
Please welcome to the stage Manendra Pari from NVIDIA.
Hi, everyone. My name is Manindra Pari. I work at NVIDIA. Today, I'm going to introduce you to a revolutionary product from NVIDIA called RTX VSR. I will talk about the challenges we faced, how do we make it a product at scale, what is the relevance to the industry, and where the technology may be heading in the future. Before I start, let me talk about some background. So 90% of the internet videos are streamed at very low resolution, like 1080p or lower. And large percentage are also streamed like 720p. At the same time, 90% of the users, they have very large display. Like 30% of them, they have 4K displays. So now this creates a big mismatch when the low resolution videos are upscaled on a large display. It creates a very blurry experience. Now, compounding to that, a lot of internet videos are laden with compression artifacts. And the artifacts may be coming because this video was encoded with an old codec like H.264, or this video may be encoded with low bitrate because there was simply the streaming bandwidth was not sufficient. So this creates artifacts like banding, blockiness, ringing, and now when these videos are upraised, they create a very, the artifacts gets amplified and they get a very poor visual experience. And to solve that problem, we came up with an AI-based network called RTX VSR. Before I go into the details of that, let me show you a demo video where I will show a stitched video of a traditional scaler like bicubic versus RTX VSR. You will see the video on the left is bicubic and the right one is RTX VSR with a moving slider. So as you can see here, like the arch is becoming very crisp compared to the right side is becoming very crisp. The next one, the leaves and all on the tree are coming up very clear, and the waterfall is becoming very crisp. And this rock face, you can see very tiny details are coming back. It looks a lot more natural. And if you focus on the fur of the deer, you can see the fur is becoming very, very crisp. Now on the breeze, the wire on the breeze is basically almost gone on the left, and is there on the right. And on this video, the trees are looking much more clear and looking like a tree. And in this last gaming video, you can focus on the gloves, and you can see like a lot of details are come back up. Let me show you some more examples. Here, the video was compressed with a old codec like H.264, and as you can see, that on the lake there is a lot of blockiness. On the sky, there is a lot of banding on the left side. Now, RTX VSR cleans that up. And this is a scenario of low bandwidth scenario. Streaming bandwidth can be very, very low sometimes. On 5G network, it can be less than 1 Mbps. I'm showing an example of someone playing a game on a very, very poor network, and bandwidth is low. As you can see on the wooden deck, there are a lot of color patches and chroma artifact, and it is cleaned up on the right, looking much more natural. The trees on the left, they have hardly any details, and RTX VSR creates those textures to make it look like a tree. Another example, this is a video I captured on my phone, and when I'm moving the camera, basically it creates a lot of motion blur, and it's very hard to look at. It's very, very blurry. And RTX VSR is making it a lot sharper. So what is the RTX VSR? It is an AI processing network that generates a high-quality, high-resolution video from a low-quality equivalent. BSR stands for video super resolution. So of course, it has super resolution, but at the same time, it has compression, artifact reduction, and also deblurring baked in. So I will illustrate this through this picture. So you are starting with a 1080p image, and then it is upsampled to bicubic. So what the network does is it learns the residual compared to a bicubic version. So the 1080p video is upsampled to 4K, and the network has seen millions of images. It knows that in the compressed video, which was uppressed from a low resolution, where the details might be lost, where there are compression artifacts, and it predicts, the AI predicts the residual. And the residual are added back to the bicubic images, and it creates a very clear, crisp image, a 4K image, as you can see on the right. So we productize this technology on our 30, 40, 50 class GPU. We integrate this part of the browser like Chrome, so that when someone is watching YouTube, Netflix, Twitch, then the browser automatically invokes the RTX VSR. And all you have to do is just to enable the feature from the NVIDIA control panel on GeForce. And this is one of the very, very popular features that time and again we are hearing from our end users who are using our GeForce cards. And given the success of this RTX VSR as a playback solution, we basically made it into SDK. And that SDK, third-party applications can integrate into their applications running on NVIDIA GPUs and take advantage of the feature. We also integrate this as part of the VLC player. So you can just download the software and start enjoying RTX VSR. So how we productize the RTX VSR? The first part is the complexity. Today the AI course, the AI accelerators they have a lot of AI TOPS on the consumer devices. But if you take the RTX VSR in standard form, as if you create a standard implementation, this is almost not feasible to make it real time. And we did massive amount of optimization to bring it to a real-time domain, as I will go over this in this chart. So I'm showing the runtime of RTX VSR when it is appraising for 1080p to 4K. And if you take a pure vanilla PyTorch implementation, that's 36 milliseconds. No, far from being real time. And we did massive amount of optimization to bring this to around 2 milliseconds, 2.5 milliseconds. So it's almost a 15x speed up of the RTX VSR. And the way we did it is through a technique called layer fusion. And so in the standard form, the kernels will output intermediate data to the memory, creating a memory-bound scenario, which increases the runtime. So what we did is we fused all the kernels together so that the entire processing stays on chip. So that makes it very, very fast. Second thing is that we added the int8 quantization. And of course, the output has less amount of bandwidth going to memory, but our AI cores are much, much faster on int8 than FP16. So another thing we took care of is that we have a variety amount of GPUs with different capability of compute horsepower. We have old GPUs which may not have as much as horsepower. And even in the latest GPU, in many different scenarios, you may not have all the compute available to the video. So then to take care of this situation, we created 4 different modes, VSR 1, 2, 3, 4, as you can see here, and to take care of this. So the black trend line is showing the PyTorch implementation. The blue line is showing the kernel optimization, and the green one is after int8. So performance is one aspect. The next thing is quality. How did it come to this quality level? It starts with a very high quality training data set. There are a lot of good amount of training data in the wild, but they come up with the copyright. So what we decided is to just go around with a phone and captured videos from phone and cameras, captured our own gaming data, because it's highly critical for a network to be successful to have the right amount of and the right type of data to work well. And once that's done, we did a lot of innovation into the data augmentation and loss function to make the network to be ready. And once that was there, we relied a little bit on the objective metrics like VMAP, LPIPS, and all that. But as you know, these metrics are not very, they're far from being perfect. They don't correlate well with human visual system. So what we decided to do is intense amount of subjective evaluation and network optimization on the quality side. We looked into millions of test images to see where it is falling apart, where it is good, where it is bad. It's super easy to create a super resolution network, but to make it work across a wide variety of spectrums, starting from nature video to close-up of human faces, is extremely, extremely hard. It takes lot of amount of time and tuning. So that was the last part, the subjective evaluation part and subjective tuning part. And I will show how the progression is on this particular image, where I'm showing on the left side a bicubic image. And when we come up with the first version of RTX VSR, it was working mostly fine. But a few cases like this, like you see in the middle, the human face has lost some details and skin tone and all. And it basically can throw up people. People will be discouraged to see these kind of images. So we spent a lot of time to tune these kind of aspects. And as you can see on the right, what we have in the present form, it is adding these details, but at the same time, it's looking very, very natural. So given the success of RTX VSR in the playback domain, we wondered whether it can work with other kind of application. And it was a pleasant surprise that this works in many, many diverse kind of applications. I'm going to talk about 2 of them, GeForce Now, cinematic quality mode, and a collaboration we did with Cinefilm a global leader in image enhancement. Of course, every day we are finding new kind of use cases. We're doing a lot of new kind of collaboration, and we see that, yeah, it can work well in a diverse set of scenarios. So the GeForce Now. So recently we announced a cinematic quality mode for the GeForce. Those who don't know, GeForce Now is our gaming service where people play games on their not so powerful PC, and the game is basically rendered on the cloud. And then it is encoded and streamed back in real time to the users. So the problem happens because the games have a lot of high frequency details, and it takes a lot of bits on those areas. That means it starves other parts, and it looks a very patchy look. Like as you can see from this picture on the left, this is what GeForce Now till now in some scenarios. Now we fix this issue or we improve this situation with inverting the problem. Instead of doing a post-processing on the client side, we are doing the pre-processing on the server and basically applying the pre-processing so that it is friendly to the encode. It generates optimal bit, but gives a very good quality, and it can give cleaner motion, less artifact, which is a good thing. Now, I'll talk about the collaboration we did with Cinefilm. So they are a global leader who works with a lot of studios and TV companies. And their use case is that they enhance videos from multiple camera feeds at major events. And also, they, given the legacy video libraries, very old libraries, maybe 10-year, 20-year-old videos, they basically improve it and bring it to suitable for the modern delivery. And I'm putting some quotes that they added in their blog post. So using RTX VSR, the quality and details are improved by around 25 to 30% over their existing state-of-the-art solution. And adding their motion compensation and advanced noise control technology combined with RTX VSR, they are creating cinematic video at scale. So I'm showing a couple of examples here. On the left side is a very old video, very blurry to look at. And using RTX VSR, it becomes much cleaner, looks more suitable for streaming now. The next picture is basically, you can see, look at the text. The text is so blurry, and RTX VSR make it very sharp. It's as if someone with a vision problem puts on their glass, and then the visuals become a lot sharper. So where does this technology heading? So today you will see a couple of other examples of super resolution from the other companies, and a lot of companies are investing here. So it's natural that it becomes part of a video standard. What's happening in the industry is like every 5 to 6 years, a new standard comes in. But what we see is that it's increasingly hard to create visual improvements, and also the complexity is just exploding. It is not sustainable to add all these codecs in hardware. So at the same time, there is general purpose AI accelerators in almost every platform, server to mobile platforms. So, and these AI accelerators are there, irrespective of whether you use it for video or not. They're for all kind of general purposes. So it's natural that if you put this kind of video pre-processing and post-processing solution into the AI course, this can benefit the industry, and it will be a net win for all. We'd be happy to collaborate if anyone is interested, and what we see that the direction going that way, that there will be a standards on the pre-processing and post-processing side of things. So that was my last slide. Thank you all for listening. If you are interested, please reach out to me. You will find me on LinkedIn, and we can look at some collaboration where we can take your application running on NVIDIA GPUs and make it better. Thank you. If there are any questions, I'd be glad to take it up.
We do actually have a couple of questions from the audience. The first question is, what kind of bit rate savings can RTX VSR bring over traditional scaling and similar quality?
Yeah, it depends upon like what kind of metric is used. As I said, that objective metrics are not good, but we did a visual evaluation study using MOS, or mean opinion score, and what we see is that if you use traditional scaling like bicubic, Langos, and all that, compared to that, we are getting 25 to 30% bitrate savings at the same quality level.
Okay, thank you. And then our second question is, in the future, how do you foresee RTX and VSR technology evolving?
Yeah, so the RTX VSR is CNN-based. We think that the right direction to go will be transformers, VLMs, and all that. But in the current form, the complexity is just so high to put it on the consumer devices. So, but we don't see that's far out. Yeah, so that's coming.
Thank you.
All right, thank you very much.
Please welcome to the stage Ryan Lay from Meta.
Good afternoon, everyone. Welcome. Did you know that video now accounts for more than 80% of global internet traffic? I hope this is not a surprise to the audience in this room. So over the past decade, we have seen the usage of video is continuously expanding and evolving. On one hand, short-form video has become very engaging content and accounts for more than 80% of mobile traffic. With the easy access to all the creation tools and some of the cool features you have seen in the morning session, right now, it is very easy for everyone to create interesting video and share with their friends and families. On the other hand, video is also becoming a powerful tool for communication and marketing, with a lot of people, companies use it to reach their customer. Specifically for Meta, across our family of apps, every day we receive more than 1 billion video uploads and more than 1 trillion view requests. And we have already accumulated more than 1 trillion video asset in our inventory. According to the 2024 Q1 earnings report, now 60% of the time users spend on Facebook and Instagram is on consuming video. Video has become the key levers that drives user engagement, revenue growth across Meta's entire ecosystem. I'm Ryan Lay. I'm currently working as video tech lead and software engineering in the Media Foundation team at Meta. Today, I'm really excited to share with you how we deploy video super solution at scale. Recently, we have launched VSR to improve the quality for few Meta use cases. I want to share with you all the learnings and see how you can apply that into your projects. As a backend infrastructure provider, our Media Foundation team is responsible for processing and delivering all the videos our user created. Our mission is clear. We want to deliver the most optimal quality and user experience for every piece of content that flows through our system, regardless of its original quality or the devices that is viewed on. Over the past few years, we have heavily invested in cutting-edge encoding technologies to improve the quality of our delivered video. This investment including deploying AV1 and HDR encodings, and also leveraging Meta internal designed hardware MSVP video processors. Recently, we have expanded our focus beyond the conventional compression technologies to embrace AI-powered content creation tools. This investment, including leverage generative AI models to create high-quality video at source, and also leveraging video super resolution and enhancement technologies to improve the quality of user-generated content. Now we have some context. Let's dive into the agenda. First, I will explain why we want to invest into video super resolution. Then I will cover 2 use cases recently we leverage video super resolution to improve the quality of ads video and the Gen AI videos. After that, I will introduce a key feature implemented in our system to support the VSR deployment. At last, I will end with some key learnings from VSR subject evaluation. Let's talk about why we want to invest in video super resolution. When we look at where the low-quality videos are coming from, we see there are 3 main sources. First, there are videos created by our user using lower quality cameras, bad lighting conditions, or heavily compressed during the upload stage. And also, there are videos downloaded from other platforms which have already been compressed many times and re-uploaded, cross-posted to the Meta apps. Finally, there are also a lot of legacy videos in our inventory that was initially created at the lower resolution and the lower quality. For these use cases, we can leverage VSR to improve the resolution and quality for those videos. Nowadays, most of the state-of-the-art super resolution solutions leverage machine learning-based model trained on huge amount of video data. They can transform blurry and grainy videos into clear and sharper ones, make the lower resolution content looks much better on high resolution modern display. Here is a high-level end-to-end process flow of our system, and also highlight where the video super resolution can be used. On the ingest side, when we receive lower resolution and lower quality video, we can apply VSR to upscale it and create a high-quality source for downstream ABR encoding. In this case, we can leverage our robust server infrastructure to apply sophisticated super resolution models to maximum quality improvement. On the other hand, on the consumption side, due to the network bandwidth limitation, our user may still receive a lower resolution and lower quality encoding. In this case, we can deploy video super resolution to improve the quality before playback. Given the power and the compute limitation, it is still very challenging to deploy very sophisticated VSR models on the client side. So the solution applied there have to be lightweighted and do not consume huge amount of power. Similar as any technologies we deploy in our system, we also want to enable end-to-end quality logging and measurement to understand the quality improvement. Now, if VSR can be applied on both server side and the client side, then you might ask, where is the optimal place to apply it? Do I need to do it on both sides? So to answer this question, we did some end-to-end study. So here is some observations. First of all, if you can deploy a better upscaling algorithm on the client side for playback, that can always improve the subjective quality. However, as I mentioned, given the limitation of the compute power on the client side, the quality improvement on the playback side is always limited. However, on the server side, if we can apply advanced VSR algorithm to improve the quality, which can be preserved even after downstream ABR encoding and delivery. So the algorithm or solution provided on the server side and the client side can actually complement each other. So you will have to do a full end-to-end study to understand the overall benefits with the combination of algorithm you want to deploy. Our media foundation team support the solution on both server side and the client side. For today's talk, I really want to focus on the solution we deployed on the server side. Now I have covered why we want to invest into super resolution. Let's talk about 2 use cases we recently leveraged super resolution to improve video quality and user experience. As a backend infrastructure provider, we want to provide a range of solutions with different complexity and quality. With a growing demand for AI-powered features, which means the GPU resources is at high demand, create a need for alternative solution. Our partnership with Intel enabled us to deploy advanced VSR models on standard x86 CPU infrastructure. By leveraging Intel's RVSR SDK and OpenVINO toolkit, we can leverage a middleware stack that hides all the complexity of AI-based video processing. The RVSR SDK supports few video enhancement features, including some pre-optimized and high-performance VSR models. They can be exposed through standard FFmpeg filter plugin, which make it very easy to integrate into our existing process flow. The ability to deploy advanced VSR model on generic CPU infrastructure unlocks the operational scalability and cost efficiency across our infrastructure. Recently, we have deployed this CPU-based VSR solutions to enhance the quality of ad videos. The deployment has shown great success. From this simple image, you can clearly see the quality from two different VSR models is much better than the conventional upscaling algorithm. VSR is also enabled in recent launched Meta Rescale feature, which represents the cutting-edge AI-assisted content creation. Meta Rescale can convert short video clips and photos by changing the outfit, background, lighting conditions, and artistic style based on the user prompt and preset options. The movie model is used in the background to generate a restyled video. Here is the high-level processing flow. First, the input video will go through a pre-processing stage, which converts video into certain format for model inference. After the restyled video is generated, it will go through this optional post-processing stage, in which, based on the user request, we can apply frame rate up conversion, super resolution, and other enhancement features to create the final high-quality video. Again, as you can see from this side-by-side comparison, the quality from super resolution model is much better than the conventional upscaling algorithm. In the restyle use case, in order to reduce end-to-end latency, we have to deploy a GPU-based super resolution model that runs together with the movie model on the same GPU host. To further reduce latency, we can split the video into multiple segments, process them in parallel on many GPUs, and then merge them together eventually. Now I have covered the two use cases that leverage VSR. Let's look at the key feature implemented in our delivery system for VSR deployment. For every video we received from user upload, in the backend, we will create a data model, manages the lifetime and all the events happen on this particular video. So when we apply VSR or enhancement on a particular video, we are not creating a new video. Instead, we are creating a different version of the video. In order to manage the processing and the delivery for different versions, we expanded our current data model implementation to support multivariant. So with multivariant support, we can apply different enhancement technologies on the video to create a different variant. And then we can control which variant should be encoded and delivered to the end user. Now I have covered some technical pieces on how we enabled VSR. Let's look at how we measure the quality improvement and ensure VSR is actually delivered the quality improvement to our end user. So when we deploy VSR at the Meta scale in production, we see many challenges. From quality point of view, first, we need to decide which model or solutions to use. As you might know, there are many, many video super resolution models and solutions. We need to evaluate their complexity and quality and decide what to use. Unlike in the video compression domain, there are well-established quality metrics or methodologies that can be used to benchmark different codecs For VSR, there's no reliable quality metrics can be used to measure the quality improvement. And also, there's no reliable mechanism to detect if there are certain artifacts could be introduced by VSR. So there are a lot of internal product use cases can leverage VSR to improve the quality. And they all have different requirements about how to opt in such technology. When we enable VSR, it is very critical to make sure it preserves the creator's intent without fundamentally changing the content. To address these challenges, we kind of rely on large-scale, crowd-based subject evaluation to help us understand some questions. First, can we leverage subject evaluation to benchmark different VSR solutions and measure the quality improvement? Second, how does objective quality metrics correlate with subject ratings? Third, can we leverage subject evaluation to identify artifacts or potential risks with different VSR solutions? To support the subject evaluation, we built this automated framework that can show the videos processed by different solutions side by side. We then ask the rater to provide a mouse score for each video, also identify their preference. On top of that, we also ask the rater to see if they can identify any artifacts or issues with a particular video. After gather all the raw ratings, we leverage the state-of-the-art methodology to analyze the data and get the insight. After many rounds of subject evaluation, we have identified the reliable objective quality metrics, which is the UVQ developed by Google that shows good correlation with human subjective reading. So for the chart on this slide, on the left-hand side, this is the mouse score improvement from the subjective rating. Here, the color in the purple indicates the statistically significant improvement from different VSR solutions. The chart on the right-hand side is Delta UVQ score for the same set of VSR solutions. As we can see, the Delta UVQ score have quite strong correlation with human subjective rating. On top of that, if we further analyze data, we also found out the VSR is only effective for videos with medium to higher quality. If the original quality of the video is already very bad, then applying VSR may not show the noticeable quality improvement. As we can see from this chart, after we group the data based on the input UVQ score of the input video, we can see that only the video with relative medium to higher UVQ scores can show the quality improvement from VSR solutions. With that, here's some key takeaways. Deploying VSR at meta scale requires overcoming significant technical and operational challenges. From this journey, we have learned that VSR is the effective technology to improve quality of the video and the user experience. To support large-scale deployment, we need to support a portfolio of solutions with different quality complexity and also can run across different platforms. Last but not least, we must combine it with careful quality evaluation to preserve the creator's intent and target to specific videos that can benefit from it. What's next? So moving forward, we want to expand beyond the super resolution and explore other video enhancement technologies. Also, we want to experiment enhancement for other use cases like calling, RTC, and also leverage solutions that are targeted for mobile client. Last but not least, we want to continue investing into quality evaluation and media understanding. I feel this is a common challenge everyone in the industry will be facing when trying to deploy AI-based content creation or enhancement. So we want to share our learnings and collaborate with academia and the industry to solve those challenges. With that, thank you very much for your attention. I'm now open for questions.
And we do have a couple of questions from the audience. The first of which is, in your talk, you've covered 2 use cases that leverage VSR to improve quality of ad videos and Gen AI videos. What are the main differences between these 2 use cases from a quality point of view?
Yeah, great question. For the ads use cases, we are mainly trying to process the legacy ads videos that originally created at lower resolution and lower quality. So you might also notice that in the ads video or images, they have a lot of logos, text, overlays, stickers. So when we apply super resolution, it is very important to make sure the quality of those graphic components is very good, especially on the fine printed text. So we want to make sure the text is readable after applying super resolution. So to specifically address those challenges, we actually have to retrain some of the model with some specific data set to improve the quality of the text and overlays. However, on the Gen AI video, typically the quality of the video generated from Gen AI models, they are already quite good. They don't have typical compression artifacts you can observe from user-generated content. But sometimes, because those Gen AI models, they are trained on cinematic movies. So typically, in order to simulate the cinematic effect, sometimes you can see different level of blurriness or sharpness in the background and the foreground. So we just need to improve the sharpness of those videos to make sure it looks good after the upscaling. Yeah, that's a good question.
And then we have one more question from the audience. In your talk, you mentioned that the artifacts could be introduced by VSR. During the subjective evaluation, what are some of the typical artifacts that you've seen?
Yeah. So the common artifact we're seeing is over-sharpening or over-smoothing with some model, which could make the natural video looks like animation, non-realistic. So those are some of the very challenging problems. And other than that, there's also some VSR model could introduce slight color difference. And also some of models could introduce in temporal inconsistency because if they are originally treated based on static image. So those are some of the common problems we are seeing.
Thank you so much for those answers.
Thank you. Thank you very much.
Please welcome to the stage Blaise Thomas from Agora Labs.
Hi, everyone. My name is Blaise. I'm a solutions architect at Agora. Thank you so much for having me here today. I'd like to call on you to use your imagination to think about what conversation with AI is going to look like in the future. Because a great conversation goes beyond the token. It's not just about the words that are exchanged. It's also about the emotion, about the memory and the meaning. Right? That's what lasts. When you have a great exchange, you're challenged to think more deeply, to feel more deeply. It should help you deepen your understanding, challenge you. And so imagine AI personas that can kind of meet us on that level, that are as relatable as maybe your favorite influencer, but infinitely more grounded in truth. And I'll add to this a personal ambition. I think it can help solve some of the problems that we're facing at the moment. Like, for example, conversation's kind of synonymous with democracy, right? But if we're being honest, we've been wielding it a little bit like a toddler with a flamethrower. And so this is just a personal hope and ambition. But maybe, maybe it can become a voice for reason and steadiness and fact-checking and some other great things that will help solve some problems beyond what we expect. So that's kind of what my talk's about today, is like, how do we innovate with conversation? At Agora, we know a thing or two about powering conversations. Actually, each month we deliver about 80 billion minutes of conversations across the internet. And our SDKs have touched about 3 billion devices worldwide. We support thousands of apps. It's very likely that you've used Agora before, maybe even without knowing it. We're actually a white label SDK way of integrating conversations into applications and websites. And yeah, it's, like I said, it's very likely that you've used Agora before, even without knowing it. I'll dive into the network a little bit more during the talk, but the highlight of it is that all of this happens on the only SDK-enabled global real-time network that is built specifically for conversation and for engagement and interaction. SDRTN, we call it. It's our software-defined real-time network. Boasts near 100% uptime. Proud to say that we were completely unaffected this week by any outages. And we're able to maintain fluid conversations, even when over 60% of packets are lost. Got global coverage, over 200 points of presence worldwide. And we really focus. We have been obsessing for over 10 years on this problem, which is quite a hard problem, real-time communication, of delivering great conversations. So in short, we've been building the internet for conversations. And SDRTN extends naturally from human to now human to AI conversation. This real-time overlay is seamless across devices, across geographies, and now hopefully the interface for conversations with AI. So here's the thing. Let's talk about a couple of the problems. What I'm alluding to here today is not the fully integrated products that many of us have interacted with and had great conversations with already. What I'm talking about is if you want to try and innovate and go out there and build new conversational tools yourself, you're going to run into a couple of problems, right? Latency can really break the magic, okay? Interruptions don't necessarily land smoothly either, right? There's nothing worse than when the AI just kind of barrels on, or worse, it freezes like you've offended it. And then noise can really ruin the accuracy, right? Cars, wind, background noise, all of the things that make us human and makes AI stumble. And then there's another problem as well, which is this is for the innovators, right? So there aren't really that many tool chains out there, or some of them are actually really vast and hard to put together. And arguably, there's not very much mid-pipeline control for how you piece these things together and how you insert your own logic. So I see an innovation bottleneck. Potentially it's hard to iterate and difficult to differentiate. So the problem isn't just that AI conversations feel less human. It's also that innovators don't have the freedom to build the stacks that best serve their users. So I'd love to tell you about the solution that we've been working on. It's in 3 main parts. The first one is the network. The second are tools like voice activity detection and turn detection, and all of the tools that give AI agents human-like conversational instincts. And then the third one is kind of what brings it all together, is this flexible engine, which you can invoke with a single REST API call and string together your own tool set of choice, your own ASR vendor, LLM, TTS, etc. And then to wrap it up, I'll show you a couple of cool case studies that I've actually been working on personally in the real world, and tell you about those as a few real-world examples. So the network. This is our core technology. Over a decade of R&D, real-world problem solving, and trillions of minutes at this point delivered. At the heart of SDRTN is a mesh network, effectively a private mesh network, which maintains simultaneous routing paths in tandem between endpoints. And we continuously monitor traffic and optimize across these different routes so that fallback routes can be automatically engaged wherever outages or network interference pops up. So that, combined with innovations on the codec level, plus forward error correction, allows us to sustain fluid dialogue, and this is just for between humans, right? Even under extremely high packet loss conditions. The result is sub-second latency across continents. And for me, the takeaway here is all about building latency out of the system, which allows you to build trust back into the conversation. And sub-second latency really matters. The public internet alone can't deliver it. We actually have a white paper about SDRTN in which we laid out the inherent limitations of best effort routing for real-time communication. Packets hop across various tiers of different ISPs in pseudo-random ways, and each detour compounds delay until the magic breaks. In addition to that, if there's a problem between any individual pathway, there's no guarantee for how recovery will happen or if indeed it will ever happen. And so SDRTN is designed to service this. It's designed to solve for this. Instead of relying on a single path and a single media relay, our mesh network maintains multiple routing options, which are constantly measured by ML algorithms, measuring congestion, latency, and packet loss. And it's able to automatically and dynamically reroute when congestion is detected. This is how we deliver sub-second latency globally, and why we're trusted when every millisecond counts. So that's just a little bit about the network. I'd love to talk about voice activity detection and a few other tools right now. And I'd like to start by saying, I'd almost like to ask for a show of hands, but I'll just make this statement. If you have ever tried stitching together a voice transcript with an LLM completion endpoint and then speech synthesis, you will know that this is not enough to create a conversational interaction. There are too many things that break in there, and I alluded to some of them in the problem statement. And so tools like proactive listening, natural hands-free engagement, voice activity detection, etc., these are essential to the pipeline. They're not just utilities. They're what makes it work. They're what gives the AI human-like conversational abilities. In practice, this means that you can cut in, redirect, or even change your mind mid-sentence, for example, when you're talking, or it allows you to really latch onto your voice and understand what it is that you're saying when other voices are present. Maybe I've said enough, and I can just play a quick video that sort of shows some of these in action. I'll play that, and then we'll talk about the VAD afterwards.
Hello, this is Agora Conversational AI. How can I help you today?
Please talk about what you think is a good habit to keep mental health.
I think one good habit to keep for mental health is practicing mindfulness. You know, taking a few minutes each day to focus on your thoughts and breathing. It can really help calm your mind and reduce stress. So, do you currently practice any mindfulness exercises or meditation?
Stop talking. Hello, I have a question about my account. Can you check that for me?
I'd be happy to help you with your account. To get started, can you please tell me a little bit more about what you're looking for? Like what specific information you...
Please list a few environmental actions that you think help protect the Earth. Please limit your answers to about 40 words.
Spent the majority of your childhood?
Wait, I don't think I can list things, but I can say having a stable internet connection and secure servers really help protect my work and keep conversation.
Okay, simple but effective, right? The last one is perhaps the trickiest one to understand because you're hearing so many voices. What that example is trying to show is that you can use fingerprinting on voices to really latch in to one voice specifically. It's pretty cool stuff, and it's part of the tool stack. The idea with this, obviously, is so that the AI can still track, no matter what's happening, right? If you're in a busy hospital or a car or a crowded place, the AI can still track and zero in on the person it's having a conversation with. So I think I've said enough about those tools. Next, I'd really love to fast forward to my favorite part. This is where it all comes together, and this is the conversational AI engine. So this is where we combine the network with the tools like VAD and turn detection, and how you can invoke an actual agent to join a channel and create a conversation. So this is how we're solving for the flexibility problem. The engine is fully customizable and composable. On screen right now, you'll see just a few of the vendors that we currently support, but we actually support many more through our open source framework, which I'll detail in a moment. And using the engine, you can stitch together a custom cascade with your chosen ASR vendor, LLM inference, and TTS provider. And instead of having rigid flows, you now have an open canvas where you can test out different things, see what works for you, and really design a framework for conversation. And here's the magic. Between those steps, you gain the freedom to further shape the interaction to your needs. So for example, after ASR, you might want to look something up in a vector database, or call a REST API for real-time data input. And then after the LLM inference, you might want to enrich a dashboard, save something to a database, carry out some kind of other interaction that is necessary to build into the flow of how you're interacting with the software at that time with the voice agent. And all of this happens while still delivering that spoken response. So now what we're proposing here is instead of being boxed into a rigid flow, you now have an open canvas to design the conversation as you intend. And so the result is a choose your own vendor, bring your own key solution that you can invoke with a single REST API call. And it's so easy that you can test multiple configurations in parallel, so you can really see what works best. And you can even deploy multiple stacks within the same application based on your users' needs and their unit economics. Right? This is something that we've started to see, is you don't even just use this for experimentation, you actually use different stacks in production. And so this is what I promised to talk about, the open source framework that backs all of this. So this is our 10 framework. And if you check this out, you'll find actually all of the tools that you can recreate the whole pipeline from scratch, all with open source code. The 10 agent is the source of the 10 of our conversational agent, conversational engine, pardon me. You'll also find the open source code for voice activity detection, turn detection, etc. Lots of cool things available there. And of course, we welcome contributions. And this is a great pathway to introducing new integrations into the Convo AI engine. So this is my favorite slide in the whole presentation. The reason for that is this highlights the standout features of Agora, that we're truly an accessible network. And this is something that differentiates us a little bit. We have SDKs available in so many different frameworks and like languages and frameworks, etc., from native to web, server side. You can also dial in via a phone number if you would like, or call out to phone numbers. We've recently added SIP integration for WhatsApp, so thank you to all the awesome people here who are helping us with that. And I'll talk about the IoT device as well in a little bit. So you can even put conversational AI into a key ring or a slide clicker. But the thing I'd like to underline here is that this is the part that's a little bit novel, because to create a conversational channel in SDRTN, you can come in from any of these points. And all you need to do to create a conversation is just say this is a channel and join it. And then a conversation happens. And at that point, you can add in as many other human or AI users as you would like to have a new, completely novel kind of conversation. So literally anything is possible. We're not just talking about one-on-one conversations between one human and one agentic AI anymore. It can be much more broad and open than that. So Agora's device kit R1, this is how you can bring conversational AI into a slide clicker or maybe a cuddly toy or various different other things. It's built on the BK7258 system on a chip, which is very similar to an ESP32. Yeah, we're really looking forward to launching this. We've got a few cases that we're working on already, and if you ever need ESP-level device that can have conversational AI, please think of us and reach out and see if we can help you with your pursuits. So in summary, you've got universal device compatibility, right? 30,000 plus different devices that you can access the network from to create a conversation. Selective attention locking, and all of the tools that you're going to need to make sure that that conversation is human-like and fluid. Production-ready engine that you can invoke with a single REST API call. And then network resilience to make sure that that conversation remains fluid, uninterrupted, and of high quality. This isn't just theory. It's working in the real world. On screen, I'm about to share a video. This is Amoga Shriyangarajan. He is CEO of Carbon Origins, who in my opinion is one of the coolest startups here in the Bay Area. Their mission as a company is to make robots commonplace. And what they do is they retrofit heavy machinery like bobcats, skid steers, or excavators with teleoperation or self-driving equipment so that they can operate heavy machinery in situations that are either too repetitive or critically too dangerous for humans to operate, like wildfire response. In this particular demo, you'll see a video of one of the autonomous systems that they have at an aggregate sorting and distribution yard just nearby in San Leandro. And these machines, in this particular scenario, are completely autonomous. So what they're doing is they've created something called Constellation AI, which allows you to actually just, from a single operator, orchestrate multiple different machines. So that's one of their implementations of conversational AI. But they've actually used it multiple times. If you're teleoperating a vehicle in VR, you can actually talk to an AI which has all of the information that you need about that particular device that you're operating. It'll run you through the startup procedures, help you with your safety checks and stuff like that. So they're using it in multiple different ways. But this is the Constellation demo. So take it away, Amoga.
Hey, I'm Amoga, bringing you a behind-the-scenes look of Constellation AI. Constellation AI is device agnostic. It can run on smartphones, tablets, laptops, desktop computers, and the user can be anywhere in the world. You're seeing the red virtual geofence within which our autonomous skid steers can operate. See, there's one machine live, Bobby 2. And then on the left side, we have Constellation AI chat window. Good afternoon, Constellation. How's it going?
Good day, Amoga. I hope you're doing well. What would you like to tackle today? Whether it's starting a mission, checking on Bobby 2's status, or planning out some operations.
All right, Constellation, I drew a little box here on the right yard. Go ahead and create an autonomous spray down loop.
You got it, Amoga. I see the box you've drawn on the right yard. I'll create an autonomous spray down loop for that area and get it executed right away.
You can see in the rear view camera here the autonomous path that it's planned that it's going to take. All right, looks like the mission is complete. Good job, Constellation.
Thanks, Amoga. Glad it all went smoothly. If there's anything else you'd like to set up or check on, just let me know.
Truly mind-blowing stuff. I really recommend reaching out to Carbon Origins. They're just so cool, so smart, innovating at a furious rate. It's really cool stuff. OK, so the next use case I'd love to show you, this one is probably what you imagined when I started talking about conversational AI. It's a little bit more of a traditional use case, but I've been working quite closely with Intel Swift, and they're really awesome. Their use case is agentic AI helpers to engage customers who need support for their resolutions. And in particular, the first project that we kicked off with was for a banking institution in Ukraine. And Ukrainian represents some interesting linguistic challenges on its own. Not only this, their customers actually really need this because Ukrainian is largely only spoken in Ukraine. So trying to outsource 24/7 help cases in Ukrainian isn't really possible. So they're really keen on this kind of stuff. And I think the takeaway here is that being able to battle test various different vendors for ASR, as well as the LLM inference and the text-to-speech, really allowed them to create something that delighted their customers, to really help resolve their problems and make it so that they'd never even have to talk to a human if they don't want to. They can just talk to the AI agent and fix everything they need to do. So props and shout out to Intel Swift as well. So what's coming next? Well, quite a few things, to be honest. We're adding video with video avatars. We've got a couple demos. I'll share the link to the demo in a second. But with Acool, HeyGen, and Trilliance, and Anam.ai, we've done a lot of stuff with video, which is really cool. But I think also what's exciting is many-to-many conversations with AI in future. That's one of the things that's coming next, and that's already possible, and you can do it if you play around with these tools. And then maybe the last one is conversational UI. So how does software start to operate when you no longer have to sort of type and click and search through things, but instead you can just talk to it. And it can talk back to you, and it can really help you fulfill your mission. It unpacks user experience in a completely different way. And this is something that we're starting to see, and I'm particularly excited about. Here's the link to the demo. I'd love to invite you to try it if you ever want. And there's lots of good stuff in there. But so where does this all lead? Well, back to the vision that we started with. Maybe conversations with AI that can fix some real-world problems, that can make us wiser, maybe nudge us past some of our hidden biases. Maybe they're grounded in truth. I believe that this future will not be built by one company or a single model, but by collaborating and through inclusivity, by combining the best brains and the best models and the best tools with the best networks. And this is exactly where we want to affect innovation, and this is what we're working on delivering. I think conversation has always been the power of democracy, and if we do this right, it could be just one of the other things that we fix by doing this right. So I'd like to say thank you so much for listening to my presentation, and invite any questions if you have any. OK, we might not have any questions. That's fine. Well, please reach out. Thank you so much for your time, and see you afterwards.
Please welcome to the stage Kareem Helwani and Hoang Do from Meta.
Hi, everyone. Last year at Attendees at Scale, we presented the real-time communication stack for human-human conversations. And today, we're going to talk about the work that we've been doing to enable conversations with AI voice assistant. AI voice assistant is being integrated deeply and broadly into our daily life. Here are some stats about the adoption of AI voice assistant in the industry. 8.4 billion global voice assistant by 2024, 149.8 million US voice assistant users. And then look at this. Voice is a sticky interface. 57% of daily users using voice daily. At Meta, we've been bringing AI voice assistant into our family of apps, including WhatsApp, Instagram, Messenger, Facebook, and the standalone Meta AI app. We also been bringing AI voice assistant into our wearable devices so that we can unlock the power of AI on the go. Whether you are on a busy street or sitting comfortably on your couch, you still can interact with our AI voice assistant using our smart glasses. Some typical use cases for AI voice assistant include social coordination, information gathering, productivity, and entertainment.
Thanks, Hoang, for this mind-blowing stats and very interesting use cases. But let me ask you, haven't we all experienced some awkward moments interacting with AI? For example, it is picking up some TV, responding to it, or picking up a side speech and giving an opinion to it?
Yep. One of the main challenges with AI voice assistant is interferences, which can be very disruptive to the user experience. This includes 3 problems. One is background noise. Second is side conversation or side speech. And third is acoustic echo. Unlike humans, who can recognize and tolerate some amount of side speech, echo, or noise, the AI voice assistant doesn't have such capability, and it's our job to bring such power to the bot. In our analysis, more than 50% of the calls with AI voice assistant suffer from some sort of background noise or side speech. For example, if there's some TV playing in the background, or if the user is talking in a crowded place. And these interferences can falsely trigger the bot to respond or interrupt the bot when it's responding. Also, the bot can be interrupted by its own echo if the user device acoustic echo canceller or AEC doesn't work well.
In this talk, my colleague Hoang Do and myself, Karim Helwani from Media Foundation here at Meta, will present some of the advances in real-time communication to enable natural conversational AI. The agenda of our talk is, first, we will introduce our solutions, present some results, and then lay the road ahead. Our solution to conversational AI, real-time communication, is a multi-layered audio AI stack that targets each of the pain points of conversational AI separately, layer by layer. Our development is driven by our vision to enable a fluent and natural artifact-free conversational with AI bots that is as natural as talking to another human being.
Thanks, Karim. As we presented at RTC at Scale last year, here is a typical audio stack for human-human communication. Just to refresh, on the capture side, the audio is captured by the microphone on the device, going through some on-device audio processing, which typically includes an acoustic echo canceller, AEC, noise suppressor, NS, and automatic gain control, AGC. The processed audio signal will then be encoded, packetized, and sent to the network at some fixed time interval, for example, every 10 or 20 milliseconds. And then on the receiver side, the reverse processing is done, where the audio packet is received in a jitter buffer to account for any network jitter or packet loss due to the transmission. then get decoded, and then going through some receiver-side audio processing. For example, some render-side gain control or some dynamics processing, and then gets played out through the speaker. However, for human-machine communication, the previous architecture has to be changed to address a few new requirements. First, the user would expect the bot to be available immediately after initiating a call. Second, the user would expect the bot to be responsive and also fully understand the questions from the user. To address these new requirements, we make the following changes. First, we start recording and buffering audio on the device as soon as the user opens the microphone. And when the connection to the server is established, we burst these audio packets faster than real time to the server. And then on the server side, we optimize the decoder and jitter buffer to be able to absorb these faster than real-time audio packets. And this is possible because the bot doesn't require the audio packets to arrive at some fixed time intervals like humans do. Second, we also optimize the jitter buffer for loss resilience instead of jitter buffer, so that we can keep the size of the jitter buffer as small as possible, and therefore reducing the response latency. And third, we optimize the on-device audio processing pipeline, for example, the echo canceller and the noise suppressor, to be able to preserve more of the user's voice, especially during double talk, so that the bot has a better chance of capturing the question from the user, even at some expense of some echo or noise leak, which can be handled later on the server side. These, however, only provide some baseline robustness against interferences. And in the next few slides, Kareem will walk us through what we are doing on the server side to handle the interferences better.
So by default, on the back end, the LLM is not interference robust. So we need to make it interference robust. How do we do that? One approach is completely in a data-driven manner, basically making the model organically cope with the world by exposing the model to noises, side speech, and some echo artifacts during training. This approach offers some baseline robustness to interferences. However, it quickly reaches its limits. And the reason for that is because we have, in this approach, to cope with conflicting requirements. On the one hand, we would like the model to be responsive and respond to any user prompts. On the other hand, we want the model to be robust to side speech and ignore some of the speech. A more targeted approach is a modular approach. And this is what we have built in our multi-layered AI audio stack. So a lot of the innovation in machine learning has been shown with end-to-end training. However, modularity has been shown to be very reliable in engineering in human history. Let's, for example, look at an airplane. If an airplane would have been completely based on training data would have been coming from birds, and then the airplane would have looked like a pigeon. However, an airplane has very little in common with birds. They both can fly. However, try to replace a wing or upgrade an engine for a bird. So this shows actually how much gain we have from modularity. Modularity helps us with debuggability, with explainability, and also with flexibility, incorporating user feedbacks. And here is the overview of the final system, where our multi-layered audio AI stack is supplementing the LLM against interferences.
Thanks, Kareem. In the multi-layer audio AI stack, we tackle the interferences explicitly, layer by layer. In the first layer, we have a machine learning-based noise suppression, whose job is to suppress any non-speech background noise and only let the speech signal to go through. The second layer is a voice clarity detector, whose job is to detect the device-targeted speech from other background speech. The third layer is the primary speaker segmentation, which helps us to segment the main user speech from other side speech. And last but not least, we have an echo detection and suppression model to eliminate any echo in the signal arriving at the bot. Next, we're going to dive into the voice clarity detector module. The voice clarity detector module employs a voice activity detector to detect any speech activity. And then it uses an adaptive statistical model based on 3 features: clarity, centroid, and energy, to detect if the voice activity comes from the device-targeted speaker or from some background speakers. Clarity detects the proximity of the sound source. If the sound source is closer to the device, then the clarity will be higher. Centroid is the center of mass of the spectrum. It kind of tells us about the spectral brightness of the speech. For background speech, the sound will appear to be more muffled, and then the centroid value will be lower. Energy measures how loud the voice is. These 3 features in combination with a change point detection algorithm would help us detect if the voice is coming from the device-targeted speaker or from the background speaker.
The next module I would like to talk about is our primary speaker segmentation. And the role of primary speaker segmentation is to distinguish from the device-targeted speech which one is originating from the main user. The way how we achieve that is that we extract speaker discriminating embeddings combined with an online clustering module that allows us for every frame to determine if this speech frame is originating from the main speaker or from a side speaker. The model is completely enrollment-free and has very small footprint. And the reason how we achieved a small footprint is because we have a design that is DSP-informed. Basically, a DNN model uses features that are well-known DSP features, such as MEL spectrogram and pitch and LPC features and centroid, and extracts these embeddings. Next, we would like to show a demo from production call with our PSS in action, PSS and VCD in action. And we will see how the conversation is going without the primary speaker segmentation when there is side speech, where the bot will start responding actually to the TV and to side speech, whereas when PSS is enabled, it will ignore the side speech.
Hey, how is it going?
It's going great. Thanks for asking. Just catching up on some news. Actually, I'm a big fan of staying informed about what's going on in the world. How about you? How's your day been so far?
My day has been going okay. Just catching up on some TV news.
Without below average conditions
Watching
in coastal communities, while our inland areas are still going to be a few degrees above average, but honestly, nothing too crazy for this time of year. There's going to be
Hey, how is it going? How's your day going so far?
It's going well. Thanks for asking. Just had a quiet morning so far. How about you? How's your day shaping up?
My day is going okay as well. I just came back from a movie and looking for some books to read tonight.
What movie did you just watch, if you don't mind me asking? And what kind of books are you in the mood for tonight? Are you still looking for those Agatha Christie books we talked about earlier?
Not as hot as Thursday. Those temperatures sitting in the low 90s, upper 80s down into the Santa Clara Valley, low 80s across.
Thanks, Kareem. Last but not least, we have the last layer to detect and suppress any echo appearing in the signal arriving at the bot. Echo is particularly disruptive to the user experience. Unlike human who can tolerate some amount of echo, the bot cannot really distinguish echo from a real interaction from the user, and therefore it can get interrupted or respond to its own echo. Therefore, we bring two mitigations to address this issue, one on the client side and the other on the server side. On the client side, we bring our software echo canceller or Barrow AC, which we introduced in last year RTC at scale, to augment any hardware echo canceller on devices that are not performing well. On the server side, we bring two mitigations. The first one is a machine learning-based mitigation based on primary speaker segmentation, where we build a primary speaker segmentation model on the bot's audio, which is the echo signal, so that if there's an echo in the signal arriving at the bot, we would be able to detect it and then suppress it. The second mitigation is a classical DSP-based echo suppressor, where the gain factor is based on the residual echo level. Next, I'm going to play a demo where the first recording is a call without our mitigation. And here, you would hear that the bot is responding to its own echo.
Tell me a joke.
Why did the scarecrow... You had a scarecrow, but I'm guessing it's not as scary as the one that won an award. Want another joke?
All right. And now we're going to play another call in production where we have our mitigations in place. And this time, the echo is free in the call.
Tell me a joke.
Why did the scarecrow win an award? Because he was outstanding in his field. Ha ha.
Clearly, we still have a lot of work to do to improve the humor of our AI voice assistant. Okay. All right. So in the next slide, Karim will walk us through some evaluations from production data and from our offline evaluation for our solution against interferences.
Yeah, thanks. So to evaluate the performance of our AI stack, we have analyzed some production calls by test users, and we saw a reduction by 54% of unintentional prompts. And this obviously helped us reducing GPU capacity by not having to process by the LLM unintended prompts. For isolated evaluation of the performance of primary speaker segmentation primarily, we have built an evaluation framework that allows us to simulate real acoustic environments and synthesize data sets with perfectly aligned ground truth labels, which allows us to calculate precision and recall rates. And we are achieving state-of-the-art recall and precision rates of about 90%, even during overlapping speech periods. So far, we have saved you from many awkward moments where the AI is trying to pitch in its opinion without being invited. However, we are just scratching the surface. There is still a lot of space to innovate, to improve conversational AI, and to maybe develop entirely new codecs targeting human-bot communication. And maybe there is also an option to standardize human-machine real-time communication. Thank you for your attention, and if you are interested, please get involved, email us, and I think we still have some time for questions.
So we have a couple of questions from the audience. The first being how to prevent training and interference mismatch with the LLM when having this AI audio stack in place.
Yeah, that's a good question. The way that we can reduce or avoid the mismatch between training and inference is to incorporate all these audio processing modules that we just described in our training data for the post-training phase, so that the model is aware of all these artifacts from the processing.
And then our second question is, what are the key advantages and disadvantages of Meta's modular audio AI stack approach compared to a more traditional end-to-end system?
Should I take it? Okay. So the main advantage, obviously, is that it is better debuggable. So it is easier to localize any issues. It's easier to explain the system behavior. And also, it is much easier to iterate. Like if we have some user feedback and there is some behavior that we have to improve, then it is much easier to localize and iterate faster. Whereas if we are relying on an end-to-end training, we might have to retrain a large model, which is expensive and time-consuming.
Of course. Thank you. Thank you so much, gentlemen.
Yeah.
Thank you.
We will now take a short break. Programming will resume shortly. at Scale product will begin in 10 minutes. Please take your seat.
Yeah. Please welcome back to the stage Parisa Zari from Meta.
Wow, the room. It's not as full as it was this morning. I think everybody's out there mingling, networking. So I'll just give it a couple minutes for everyone to get in. But we have an exciting afternoon still planned. And I want you guys to stick around because there's going to be a happy hour at the end of the day. And that is a great opportunity for you to network and connect with others. We have a series of talks still left from Meta and Microsoft. And we also have the wearables panel coming next. With that, I want to introduce Wes Castro from Meta. He'll be our next speaker. Please welcome to the stage Wes Castro from Meta.
Good afternoon, folks. Today I'm going to talk to you about how we deployed an invisible watermarking solution to process millions of videos per day at scale. But first, let me ask you a few questions. So I found this video on Instagram, but I knew I had seen it before. Clearly, somebody had copied the video and re-uploaded it onto their own account. So who uploaded the first copy of this video? You could check each one if you knew where they all were. But what if there's hundreds of copies of this video, or even thousands of copies? You're not going to check each one. And today, our feeds are full of more than just what our friends are posting. So much of what's on our feed is coming from content creators. And because it's the internet, great content gets recycled all the time. So for creators, how do we make sure that they're getting properly credited and rewarded for their work? And for non-creators, how do we make sure that we're supporting the right people and boosting the right pages? Now imagine you saw this on your feed posted by your brother. You were there that day, but they didn't have an action camera. They had some kind of smart glasses. But which ones did they have? How can I get a pair? And if I were to get a pair, how can I show to my friends what I use to capture a cool shot like this? And technology has made it easier than ever to capture your own life experiences and see entertaining content posted from anyone on the internet. But now it's even easier to imagine any moment, scenario, or possibility, real or not, thanks to Gen AI content. So imagine coming across this on your feed. Is it real? Do you think your friends or relatives would know if it's real? And even if you're pretty sure, do you have any doubts? You know, we're beyond the era of mangled fingers or other obvious giveaways that something is Gen AI content. So how can we infer if a piece of content is real or not? So there's several ways that we could definitively answer these questions. Because what these all come down to, these are content tagging problems, where we have some piece of media, and we want to attach some form of identification to it. This is not a new concept, and depending on the use case, there's many different ways that you could do this, and it could be some might be more appropriate than others. So your first option for tagging content would be a visible watermark. Imagine you have an image or video, and you slap a video there on the bottom, you slap a logo there on the bottom of that content. This is very clear and obvious, but a content creator might not necessarily want us to insert this random logo on their stuff without their choosing. Your next option would be metadata tags. So most videos are going to be in MP4 files. An MP4 file can contain structured metadata, such as the time that a video was recorded or where it was recorded. The issue with this is that if a video were to be edited or transcoded, you could very easily lose all of that information. But then what ends up being a much more robust method is using invisible watermarking, which is much more robust than those previously mentioned methods. So what is invisible watermarking, or IW, exactly? Well, it's a media processing technique that allows us to embed a message or a very small amount of data into a piece of media in a way that's imperceptible to humans, but detectable by software. And the way it does this is by modifying the pixel values of images, the waveforms of audio, or even the text tokens generated by an LLM. And media with invisible watermarking can be shared, edited, transcoded, shared on different platforms, and still maintain its identification, which is something that the previously mentioned methods can't do nearly as robustly. So we can see that there's many applications that could benefit from using invisible watermarking. And in turn, this means benefits for creators and viewers of content. So we knew that we wanted to deploy an invisible watermarking solution to do the embedding for videos to meet the needs of our product teams. We knew that it needed to be fast, not degrade visual quality, have excellent detection accuracy for extracting the watermarks that we embed, and not significantly increase the bitrate of videos that are using it. Because in the end, IW isn't free. You have these 4 axes, and they're interdependent in such a way that if you were to optimize for one, you could very easily come at the detriment of another. So in the end, you have to make the right trade-offs somewhere. And the way you would make those trade-offs is by tuning various knobs, making smart algorithm and model architecture changes, and even choosing the right place to deploy your service on. So I'm going to talk about some of the challenges that we faced in deploying an invisible watermarking solution at scale, from choosing the right place to deploy the service on, how we optimize the solution, taking various trade-offs into account, and then end with some key learnings from the experience and some future plans for invisible watermarking. So first, let's take a look at how we choose the platform to deploy our service on. So invisible watermarking uses a neural net model, so we thought that GPUs would be an obvious requirement for our service. But what we'll find is that after a series of experiments, we actually decided to not use GPUs at all. And to understand how we made that decision, it's good to go over the system architecture. So what this shows is at a very high level how the system, the server-side embedding pipeline works to add an invisible watermark onto an existing video. So the way that works is we use FFmpeg to decode frames from a video. Once we have the decoded frames, we pass that to a custom FFmpeg filter that will generate an invisible watermarking mask and put that on top of the video frames. And once we have these watermarked frames, we pass that to a video encoder, and then the output is a new video file that now has the watermark embedded into it. So this is pretty standard for any video processing pipeline, but that filter there in the middle is where all the magic happens, and it's where we focused the bulk of our efforts. And to get an even bigger end-to-end picture, say you have all these videos with watermarks in them, to get any value out of it, you're going to need some system to detect those watermarks to extract the messages from that media. So what this shows is how detection works. And depending on the use case, these detectors could exist in many different places, and they could be used to serve different purposes. So the way it works is we decode frames of the video into bitmaps, pass those to a detection model, and then what that detection model does is it extracts the raw bits from the message that was recovered from those frames. And then once we have that message, we can pass it up to the product level to trigger some kind of a workflow they have that would make use of that identifier. Now, we knew that we wanted this to be fast, but early on, we ran into a number of issues, bottlenecks that were preventing the service from being as fast as we wanted it to be. The first issue we had was we found that when fulfilling multiple invisible watermarking embedding requests on a single host, as we would start to basically parallelize those requests more, we would see that the latency would pretty significantly increase. And the second issue we found was that while the invisible watermarking model is very small, say it's maybe a couple megabytes, it's not really that big, the time it was taking to upload it onto the GPU and initialize the model was actually pretty significant. That ended up making it so then the latency was quite bad. And because we use FFmpeg, we can't necessarily use maybe a more optimal inference service that would allow us to load the model once and then reload it for each request that comes in. So for that first issue, we could just throw more GPUs at the problem, easy. But obviously that wouldn't be a great use of resources, so we don't want to do that. And for the second issue, we could migrate to a more optimal service that lets us load the model once and reuse it. But we would lose the flexibility of being able to drop in invisible watermarking as a filter into any existing media processing pipeline that's going to be using FFmpeg. So that's wouldn't be an option either. And we use FFmpeg extensively, so that wasn't going to be an option. So we tried a few things with this GPU setup to see if we could make it better. First thing we did is we ran a profiler on our FFmpeg process when the GPU was in use, and right off the bat we saw that GPU utilization was quite low. So to try to combat this, we enabled frame batching, where rather than sending one frame at a time to the GPU, we would decode multiple frames, send them in a single batch, and then do batched inference, which normally would be more efficient. But even with that, GPU utilization was still quite low. We thought maybe we're starving the filter. Maybe we're taking too long to decode frames for each video. So we moved all of the filtering logic to be in a separate thread. So you can imagine you had one thread for decoding frames, one thread for filtering them. But even when this was in place, we still saw no improvement in utilization or in latency. Maybe we can use the decoder that's on the GPU itself. The problem with that is that the time that it takes to initialize the decoder on the GPU is actually pretty significant. And we found that if you would just decode frames on the CPU and send those over without using the decoder on the GPU, it was actually quicker. Maybe the encoder overhead is too high. Maybe we can use an encoder on the GPU. But we're using inference GPUs, so they don't have a video encoder available for us to use. So obviously, GPUs were not going to be an option for our solution. So in parallel, we started to look into if we would be able to use CPUs alone and not use GPUs at all. So I mentioned earlier that the invisible watermarking model is a neural net, so it's going to be more favorable to run on GPUs. It does run on a CPU, but it's much slower. And from an initial benchmark, we found that it was about 2 times slower on a CPU compared to a GPU. So we tried to work with this a bit. We adjusted the number of threads used by the video decoder, video encoder, and FFmpeg, the number of threads used by PyTorch, and also some sampling parameters we have to determine how many frames are we actually generating and applying IW masks to. And we started to see an improvement. So we knew that we had this parameter space that we could optimize over, and we assumed that there must be some optimal set of parameters that should parallelize well and be able to run with low latency. So once we have that parameter space, we did a couple iterations of local tests, and in the end, we were able to get the performance on the CPU to be within 5% of what we saw on the GPU, which was great. And more importantly, you could run multiple FFmpeg processes in parallel with a negligible increase in latency. So from this, we were able to get a very rough number of hosts to run our service at the expected production load levels based on daily throughput. But those host numbers aren't going to translate to what you'd use in a distributed system, like what we run video processing jobs on. So what we needed to do was run a load test where, given a small set of workers, if we were to gradually increase this artificial traffic that we're generating to see basically what is the optimal amount of, what's the maximum amount of requests that pool can operate at, and then once we knew that, we would be able to more accurately determine what's the actual capacity requirements that we have for our service. So the way we did that is we dispatched jobs from a load testing system at gradually increasing request rates and kept an eye on the per request latency. And right before it started to go up, that was where the peak performance was. And at that peak performance, the performance was actually, from a latency perspective, basically the same as what we saw locally, which proved that the tests we did locally, or the parameters rather that we found to work well locally, would also work well at scale. And once we had this, we were able to get the proper capacity to run our service at scale in a much more operationally efficient way with CPU hosts compared to if we had continued to use GPUs. So we had solved this scaling issue by using CPUs instead of GPUs, by exploring different options and making the right trade-offs. But this wasn't the only area that required some careful attention to make sure that our service was going to be stable before we shipped it. At the beginning, I mentioned these 4 metrics. They were latency, detection accuracy of the system, visual quality, and BD rate. And you also might remember that if you optimize for one, it could easily come at the detriment of another. So you have to make the right trade-off somewhere. So I'll take a moment to talk about BD rate. And BD rate, what it is a metric that combines image quality targets, numeric image quality targets, with whatever bit rate would be necessary to meet that target. Because we wanted videos with invisible watermarking to look just as good with watermarks than videos that don't have invisible watermarking, and with a minimal increase in bit rate to ensure the best user experience. So invisible watermarking is invisible to humans, but it is visible to a video encoder. And the reason for that is that IW does incur a cost in terms of entropy, because you're essentially adding random noise you can think of to a set of frames in your video. And in turn, this leads to an increase in bit rate. And initially, we were seeing a regression in the BD rate of around 20%, which is pretty significant. And what this means is that users are going to need more bandwidth to view videos at our current quality bar, which is really not ideal. So the video seal paper, which was released by FAIR last year, introduced a temporal sampling method that allows you can use to apply a single invisible watermarking mask to multiple contiguous frames and like a set of frames, rather than computing and applying it to single frames at a time. So this will reduce your compute needs and also reduce your BD rate impact. And this makes sense, because a video codec is going to be encoding the differences between frames. So if you're repeating this mask between adjacent frames, you're going to have less differences to encode, and your bit rate's going to be lower. But the cost that we found from this was that the detection accuracy to extract the watermarks from those frames was pretty significantly reduced. So we couldn't really use that. But we were able to come up with an alternative sampling method that allowed us to reduce the BD rate impact all the way down to 6% with minimal impact on detection accuracy, which was great. So another issue we found was that the invisible watermark was actually very noticeable. You had very, very bad visual quality, similar to the artifacts you see up here. So that invisible watermarking mask needs to be strong enough that a video can be transcoded multiple times, and we'd still be able to extract the watermark that was in those. But it should never be visible at all to the human eye, like you see here. So usually we would rely on a quality metric like VMAF or SSIM that would give you a numeric representation of the quality of a video encoding compared to some reference encoding, say a video with and without a watermark. And when we used invisible watermarking, we actually were seeing consistently high quality metric scores, even though there were these very noticeable artifacts. And the reason for this is because VMAF is going to be tuned to quality loss from lossy video compression, and SSIM isn't really tuned to human perception. So neither of these metrics were going to be ideal for IW. We were able to resolve this using a custom post-processing technique that we iterated on using manual inspections. So we were able to tune the algorithm to find results that visually looked great, while also keeping a close eye on the detection accuracy to reach an optimal set of parameters that had a good balance between visual quality and accuracy. So this subjective evaluation took a pretty long time to complete, but it was the last hurdle that we had to overcome to unlock deployment of our service. So to wrap things up, we were able to ship a scalable solution with excellent latency, visual quality, detection performance, and with a minimal impact to BD rate. We weren't anticipating that we'd be able to migrate away from GPUs. We didn't think that'd even be possible. But in the end, it actually ended up being a much more operationally efficient and scalable solution once we had the right optimizations in place. We learned that metrics like VMAF and SSIM don't fully capture the perceptual quality degradations that invisible watermarking can introduce. And this is what required us to do a lot of manual inspections. So we believe that more research is needed to develop more accurate quality metrics to detect the sort of quality loss that something like IW would introduce. And with that, you'd be able to decrease the iteration time for developing new watermarking techniques. So I want to take a moment to point out that this was a collaborative effort from many people at Meta. We had our ups and downs, but we simply wouldn't have been possible. It wouldn't have been possible to get to where we are today had it not been from all those super talented people who have helped work on this project. So I want to take a moment to recognize that the contributions from everybody involved was crucial to the success of this project. So we've made great progress with invisible watermarking, but we're not stopping there. There's a lot of work still to be done. Precision and recall still remains a pretty big challenge, and our North Star goal is to reach 99.9% precision and greater than 90% recall accuracy when using IW. This is going to require tuning different model parameters, pre- and post-processing steps, and video encoder settings. And in the end, we see invisible watermarking being this reusable filter block that can be dropped into a range of different use cases for a range of different products without needing product-specific tweaks and with minimal impact to the user experience. So whether it's tagging of AI-generated content, identifying the earliest known copy of a video, or signaling to your friends about these cool new smart glasses that you got, we see invisible watermarking as a tool that benefits creators and consumers of content in a robust and transparent way. So thank you all so much for your time. And if you're interested in solving problems like this, please feel free to reach out to me. Thank you so much.
Hi, Wes. We have a couple of questions from the audience. The first of which is, if you can tag the earliest known version of a video on your platform, does that mean you know who owns the content?
Good question. So what invisible watermarking will, the signal that gives us is we'll be able to track the first known copy of a video that's been uploaded. What it doesn't show us is the ownership of that video. So we can't necessarily say that if a video was uploaded, that the first person who uploaded it was necessarily the owner of that content. So that's an important thing to remember.
And another question for creators, couldn't you just use this to take down all of the other copies of a video?
Yeah, that's also a good question. You could, but going back on that previous question, because we don't necessarily know who the owner is of that content, of those videos, it wouldn't necessarily make sense to take down those videos, especially if the person who first uploaded it isn't really the real owner of that content, because we don't know who the owner is. And actually, what we've heard from feedback from creators is that when people do copy their content, it's not always necessarily a bad thing. It can actually increase their reach. So it wouldn't, in that case, it would be detrimental actually to automatically take down all the copies of a video. But if somebody does want their videos to be taken down, we do have existing features like rights management that does allow you to basically remove content at scale if you're the owner of that content.
Thank you.
Thanks so much.
Please welcome to the stage Ross Cutler from Microsoft.
Hello, my name is Ross Cutler, and I'm here to talk to you about how AI can and is being used to revolutionize video conferencing. But before we go there, first let's talk about a brief history of video conferencing. Video conferencing started off in 1964 when AT&T introduced the picture phone at the World's Fair. This product was really ahead of its time. It didn't have any video compression. It just sent video from one city to another using leased lines and didn't really hit adoption when it was productized in 1970. However, in the 70s, the development of compressed video codecs started. And then when the internet came out in the 1990s, video conferencing started to get real adoption. One of the first tools that was really useful was See You, See Me from Cornell University. But it wasn't until 1996 until Microsoft integrated NetMeeting into Microsoft Windows till video conferencing became popular for personal computers. In 2003, Skype launched, which made video conferencing more globally accessible. And then video conferencing really went much higher usage when mobile phones came out. And in 2011, Apple integrated FaceTime into the iPhones. It was then integrated into applications like WhatsApp, Telegram, and Messenger. And then came the rise of cloud-based platforms like Zoom, Microsoft Teams, Google Meet, and WebEx. But it wasn't until really 2020, when the pandemic hit, that video conferencing just really took off. In fact, at Microsoft and Zoom, it grew 10x within months. And the usage hasn't really decreased since then. So it needed an event like that to really make it happen. Let me show you a few images of, so this is NetMeeting, this is Skype, this is FaceTime, and this is Microsoft Teams. So since then, AI has been playing a role in video conferencing. It's had advancements in background blurring, noise cancellation, and real-time captions. But if you look at the history of all of these, the whole paradigm hasn't really changed much in decades. You basically have a webcam that's capturing people. It's being compressed and sent over a distance, using a variety of different technologies. And then it's showing the far end what that person looks like. And we're going to show how that can totally change with AI. So what I'll first talk about is what needs to be improved for video conferencing. And then I'll give 3 applications of AI, how AI can help do this. So the first, and I think this is the 3rd talk today, on how super resolution can be used to do better compression. We show like a 2x better compression and image restoration. The next is more radical, where you completely replace the video codec with an ML-based video codec, which gives about a 10x better compression. And it also does video restoration. And the third is much more radical, where you replace the video codec completely and you replace it with photorealistic avatars. And this can give 100x better compression. And it also fixes eye gaze and the appearance of people. So how do you measure the success of a video conference? At Microsoft, we use these 6 fundamental measures. The first and the most important is meeting effectiveness. This is a measure of, did the meeting achieve the business goal? The next is meeting inclusiveness. Did people feel included in the meeting? And we've shown this to be highly correlated to meeting effectiveness. Participation rate is how much people spoke in the meeting. And that's been shown highly correlated to meeting inclusiveness. Trust is how much people trust other people in the meetings. Empathy is, do they feel empathetic to other people in the meetings? Both of those have been shown to be necessary to have effective meetings. And then meeting fatigue is something you don't want. You don't want video meetings to be more fatiguing than face-to-face meetings, but unfortunately they are. Now, our goal for video conferencing meetings is that they should be as good or better than face-to-face meetings. And they should be as good or better using all these metrics. One way of looking at these metrics is shown in this graph. The top level metric, as I mentioned, is meeting effectiveness. And that's correlated to meeting trust, as well as inclusiveness, as well as empathy. Participation, how much people speak, is correlated to trust and empathy. And these are positive correlations. Meeting fatigue has negative correlations to meeting effectiveness and meeting participation. So if people are fatigued, they will speak less and the meeting will be less effective. So where are we in meeting these goals? So the good news is, if the meeting is completely remote, that is, there's no conference room involved, then we're actually doing pretty well in the first 3 of these metrics. So completely remote meetings are more effective, more inclusive, and people talk more than in face-to-face meetings or hybrid meetings where you have a mix of the 2. However, there still is less trust, empathy, and more meeting fatigue in all remote meetings. And we'll explain how to address all of these. So what's fundamentally wrong with today's video conferencing systems? Well, the first is eye gaze is not preserved. So if you go back into the AT&T picture phone, they placed the camera right above the video of the person speaking, and there was only one person there. That actually was done to preserve eye gaze. In fact, Bell Labs did the original studies on how accurate eye gaze needs to be. And it has to be pretty accurate. You can only have 1 degree of error in the horizontal direction and about 3 degrees of error in the vertical direction. But no shipping video conferencing system today actually preserves eye gaze. The video grid showing people up, in this Brady Bunch style of video also creates fatigue. You don't want like 6 people staring at you, for an hour-long meeting. The limited field of view also lowers empathy. If you can't see people's hand gestures, then it's been shown to have lower empathy compared to face-to-face meetings. High latency, and video conferencing systems typically have a couple hundred milliseconds of latency, has been shown to reduce participation rate and increase fatigue. In fact, we've shown within Teams meetings, for every 100 milliseconds of extra latency, it reduces the participation rate in the meeting participants by about 20%. So latency is a conversation killer. There's still some quality and reliability issues in remote meetings, and we've shown that to be correlated to lower inclusiveness and lower effectiveness. And overall, the video usage is not as high as we would like. And at least Teams meetings, it's only about 50% of the call legs use video, and that's been shown to have lower inclusiveness than meetings that have video. So one of the, I think, lower hanging fruits is, how do we increase video usage? So we did a survey 3 years ago on what new features we could add to Teams, that would help people use more video in their meetings. The first one is just video that uses a lot less bandwidth. And then it also includes low light enhancements, just making the video look better, eye gaze correction, preserving the eye contact. And a lot of people don't like the way they look on video, so they want an avatar replacement, either one that's photorealistic or not photorealistic. So the first area, how we can use AI, is super resolution. And here we can get a 2x better compression using super resolution as well as video restoration. So as mentioned in a couple of the other talks, the basic idea for super resolution is you can send video with a conventional codec over the internet, and then on the receive side, you can just upscale it. So you can send a lower res version of the video and then just upscale it. This summer, we conducted the ICME 2025 Video Super Resolution for Video Conferencing Challenge. And this challenge, we basically evaluated many different many different super resolution models. The informal winner was our own internal model that's based on the residual dense network, which is shown in the upper right here. And this model basically allows us to save about 50% of our bit rate. The lower right plot here gives the rate distortion plot. The y-axis is CMOS, and the x-axis is bit rate. So the blue curve here shows 360p video. That's not super resed. But then you can take lower res versions of that video and use this RDN model and get much better quality for lower bit rate. One nice thing about this particular model is you basically can resize it with a bilinear model, and then the RDN network just restores the video to better quality. This is currently running on NPUs, neural processing units, and it's shipping in Teams today. And here's an example of 2 videos. On the left, there's no super resolution, and on the right, there's super resolution. We get about a 0.72 CMOS improvement across our data sets, our test sets. So overall, the performance is really quite good. Okay, so using super res is kind of a hybrid approach. What if we just completely take out the traditional DSP-based video codecs like H.264 and H.265, and we replace it with a completely learned machine learning-based codec? We call that an MLVC. And the goal here is not to reduce bandwidth by 2x, but 10x. And that's a BD rate improvement of -90. So we estimated that about half of the PCs that are shipping today, or by the end of this year, are going to have NPUs. Already 100% of Macs, they've been doing this for many years. One of the best ML video codecs that we've evaluated is called DC-VC-RT. This was published in CVPR this year by Microsoft Research, and this gives a BD rate of -85, so it's 85% less bandwidth compared to H.264. This runs on GPUs right now, and it's not cross-platform compatible, which means if you encode it on one platform, you can't decode it on another. So we extended this DC-VC-RT to create an MO video codec. We made it cross-platform compatible, which unfortunately reduced the BD rate by about 10%. But then we added a perceptual loss function and region of interest encoding, which brought it back up to the original -85. We ported this to 4 different platforms: Apple's, Intel's, AMD, and Qualcomm. And one nice feature about ML video codecs is you don't have to standardize them. Standardization takes a long time, it takes many years, and we don't need custom hardware for this. ML video codecs can run on today's NPUs, and if it doesn't have an operator that you may want, you can always work around that. So this is the basic architecture of DC-VC-RT. The key thing here is that frames are encoded into a low-resolution latent, which is fused with the previous one via implicit temporal modeling. And a really nice feature about this model is that it removes explicit motion estimation, which is one of the reasons that it's so fast. And then the decoder reconstructs it using also a shared low-res module bank for rate control and efficiency. So we created 2 separate MLVC models with this architecture. One is at 360p and the other is at 540p. The speed of these models are both pretty similar. We've benchmarked this using a perceptual test framework called P.910, which we've open sourced. And we used a video conferencing data set that we released last year at ICAST. And the results are shown in the plot up here. So the top 2 curves, the green one and the red one, are the MLVC performance, and that's compared to H.265, both at 540p and 360p. Overall, as I mentioned, this gives an 85% reduction in bandwidth compared to H.264, which is really quite good. One of the really nice features about MLVC is that it exhibits a scaling law. So this means that as you have more NPU, you can get better compression. So we're just showing this at one particular point, one particular model size, but as the NPUs get much faster, then the performance, the BD rate, will improve significantly and roughly in a linear way. We also show what the actual frames per second is on this. So at 360p, this can run both encode and decode at 60 frames per second. On the Lunar Lake, it's 50 frames per second, and Qualcomm Snapdragon, it's 40 frames per second. And here's an example of MLVC on the left and H.264 on the right. This is done at 50 kilobits per second, and you can see maybe a 2 to 3 MOS improvement for MLVC versus H.264. Okay, we have open sourced the inference for DC-VC-RT here at this GitHub site. A third party has open sourced the training, and later we plan on open sourcing all the improvements that we made, the cross-platform extensions, the region of interest encoding, the perceptual loss function, and the platform-specific operations. We want to make sure this can become an open standard, and hopefully other people can innovate on it. Okay, so the third area that we want to talk about are how to use photorealistic avatars with desktop conferencing. Now this will give us 100x better compression compared to H.264, but it also fixes a lot of things like eye gaze. The idea here is you're not putting participants into video grids, but you are projecting them into a virtual space. You use eye tracking to tell who is looking at who, and then you modify the avatar to show that they're looking at the right person. There's three basic technologies for photorealistic avatars. The first is 3D solutions, and these are using meshes and skeletons. Some good examples of this are by Meta and Make Your Anchor. There's 2D rendering solutions like Live Portrait and Vasa 1. And then there's newer models that use generative video. And these are good examples of these are Runway and Sora. So I'll show an example first of Live Portrait. And one nice thing about this video is that it takes about 10 kilobits per second to send it across the internet. And that's compared to H.264, which would use about a megabit. So this is a 100x reduction. Photorealistic avatars are getting quite good. Okay. So we actually integrated that into to Teams and did some internal tests, and it wasn't quite what we wanted. Like the video quality wasn't quite there, and some people thought it was a little creepy, and I'll explain that in a couple of slides. The next one is Sora. With Sora, you can actually describe the scene. You can put avatars, cameos of people into it, and here I created two demos of Sora. On the left side, this is a video grid scenario, but the right side is really what we want, where you can just project people, you describe the scene that you want, and you can say, you know, this person says this person says that, this person looks over here, and you can create a whole scene. And the video quality is really quite good. Okay. So one question we had is, how realistic do avatars really need to be? So to answer this question, we created a subjective test framework to measure the quality of experience for avatars. It's described in this paper here, and we've measured 8 different measures. Realism, how realistic the avatar is. Do people trust it? How formal it is? How creepy the avatar is? How appropriate it is for work? How comfortable people are using it? How comfortable they are interacting with it, and how much they like it, the affinity. We also measured how accurate the emotions were, how accurate the gestures were, and how much it resembled the person. We've open sourced the whole test framework at this GitHub link. And in the past year, we benchmarked over 30 different avatar technologies with this. And as an example, this summer, we held a challenge at CVPR for photorealistic avatars. And as part of that challenge, we evaluated the top CVPR papers that were about avatars. And we also included a bunch of these state-of-the-art avatars. And the images of some of these avatars are shown here. So here are the results of that CVPR challenge where we did these evaluations. On the left side, you can see real video. So we wanted that as the baseline. And then we measured how appropriate for work the avatar was, how people were comfortable using it, all the way down to realism and trust. So one nice thing that you can see here is that one of the avatars, Omni-Human 1 by ByteDance, is statistically the same as real video. The one that I showed of me earlier, Live Portrait, is about a half moss worse in terms of realism than real video. So that's why it looked not quite right. It's also why it looked a little bit more creepy than real video. And you can just go through all the different avatars and see we've sorted them just in order what their performance is. We also measured, the facial expression accuracy and the gesture accuracy and the resemblance. Here, the Meta solution avatar is as good as real video, but the one that was as good in terms of realism, Omni-Human 1, doesn't work as well for facial expression or gesture accuracy. So some of the key results for this is that these metrics are all highly correlated. In fact, the first 8 metrics that I mentioned are correlated with a Pearson correlation coefficient over 0.95. What that means is lower realism means lower trust. It means higher creepiness. It means lower appropriateness from work. So photorealistic avatars have to be as realistic as webcam realism. And if you plot affinity versus realism, and this plot does, you'll see that there's no uncanny valley for photorealistic avatars. Uncanny valley predicts that there should be, as avatar gets more and more real, that there should be a dip in the affinity. But we found no such dip. This is super linear. That basically means the more realistic the avatar is, the more people like it. And the most realistic avatars that we found are generative video models. So models like WAN 2.2 and OmniHuman 1. And unfortunately, no avatar technology currently meets all the requirements. But the technology is improving super fast. So we expect by next year, this won't be true anymore. So in conclusion, we showed how to get 2x better compression with super resolution and also add image restoration. We showed how to get 10x better compression with ML video codecs, as well as video restoration. And we showed how to get 100x better compression with photorealistic avatars, and also fix a few things like eye gaze and improve appearance. And all of these things help get remote meetings closer to as good or better than face-to-face meetings. These are some of the papers that I mentioned. And now I think we have time for questions.
So the first question is, avatars have been included in video conferencing for quite a while. Why do you feel like they aren't more widely used?
Thanks. So products like Zoom have had avatars. Microsoft Teams have had avatars. They've all been cartoonish avatars. And as we showed on that plot, if the avatars are not real, then they have low affinity and low appropriateness from work and low comfortableness using, et cetera. So that's the main reason I think they haven't been used.
Gotcha. And then another attendee asks, how much is bandwidth availability really an issue in today's networks?
So I guess about half of the call legs in Microsoft Teams don't have enough bandwidth as we would like. So bandwidth is still an issue. It's especially true in third world countries, but even in the US, it's still an issue.
Thank you.
Thank you.
Please welcome to the stage Zhuben Cheda from Meta.
What an amazing talk. Hi, everyone. My name is Zhuben. I'm a software engineer with Meta. I'm going to be talking about feed deep dives. And really, the focus of the talk is how do we build out, launch, and scale AI applications, but then how do we build retentive experiences, the role of quality, content understanding, and reasoning models in really building these deep habits for users. So let's just straight jump into this. So I'm going to take you back to February of 2004. This is when Facebook originally launched. We brought in photos and the newsfeed, and then more recently, Reels, and so on. But over the last couple of years, we've been bringing a bunch of AI features on the app to really focus on what Facebook has always been about, which is family and friend connections, social utility, and more recently, kind of consumption of entertainment and so on and so forth. So just going to give you a quick demo of what the product looks like. So here you have a reel post on Facebook about an athlete breaking a world record. And often you want to get more details about the record itself. Or you want to actually watch them perform at other events. So you get a bunch of other reels from the vast kind of Meta ecosystem. Or you have more questions about the age of the athlete or other performances they've been having. And you get to the level of engagement where you want to follow what they've been doing so you can get more updates on their performance. So that's a top-level overview of our AI product feed deep dives on the Facebook feed. I've spoken about this at last year's conference, Mobile at Scale, around how we launched the experience and how we leveraged Llama and a bunch of other technologies to get that out. We've launched in about 50 plus countries and about 13 different languages by now. Most of last year was in really trying to get the quality in a good place. And this year has been focused on building retentive experiences, getting users who have been getting value to start using the experience 3, 4, 5, 6, 7 times, 7 days a week, and making it part of their core jobs to be done on Facebook app. So let's talk about the core challenges in building product market fit. One key piece is quality, and I'll be speaking a lot about this. The other one is around scaling those quality initiatives and how do we get the right latency and capacity trade-offs. And then finally, on Facebook Feed, any feature on Facebook Feed has a unique challenge, which is that we have to provide more engagement and more value to the user than they are already getting on Facebook Feed. Facebook Feed is one of the most kind of engaging surfaces in social media. So the bar is quite high on any feature that we are bringing here. So let's deep dive into quality. I'm going to talk about 2 case studies here. And it has a bunch of interesting challenges on Facebook Feed. So here we have a meme post on a TV show. This happens to be category 1 or category 2 in terms of the most popular kinds of posts on Facebook these days. This is just a still about a scene that's kind of pivotal in this show. The show is The Summer I Turned Pretty. I don't watch the show, but this was an interesting example, so I pulled it. If you look at the prompts below, I think this is the failure mode, which is that the AI takes this very literally and is bringing up questions about rebooking flights, rebooking fees, summer vibes. It's not really getting the momentous importance of this scene in the show. So we really need to get focus on the first thing, which is to bring good context and use the right context to bring in valuable prompts for the user. So this is how we kind of address this. If it's a video, we try and make sure that we try and get a good quality video transcript. If it's an image meme like we have here, make sure we have quality image character recognition. But on top of that, for these kinds of posts, you often have a lot of clues in the comments itself. Users are bringing in a lot of social context and discussing things. Comments have various levels of quality, so you have to get very good at figuring out what comment is reliable versus what's not. But bringing in comment context often helps you start to figure out what entities we are talking about here. What's the TV show? What are the actors? What particular episode this is? At what point in the episode this happens? That kind of context comes through comments a lot. Once you've got the comments and once you've got the entities, then you can do a web search to find much more context. So by condensing those things down into a web search or a series of web searches, you're able to get a bunch of hyperlinks from sources like IMDb and also lots of fan pages. Get that context, summarize those links, and provide that to the prompt generation model to be able to get to much better prompts. So this is the first stage of improving quality. And what we see here is that, yes, this scene was from that TV show, and the $500 extra fee was quite critical in this scene. But then we also understand how it led to the character development in this particular case and start to get to the right context. I'm going to pick another example here. This one is actually fairly challenging. Actually, it's quite challenging for human beings looking at the post as well. Here you have a post with a rooster in the reel. And there are a couple of individuals visiting a farm. That's all the information we are able to gather. There's a bunch of information about a clinic happening in June. How do we make this interesting, and how do we extract the right context here? If you look at the initial case, where we do have multimodal understanding frame by frame, we are basically getting a context that there's a rooster, and the rooster is doing a bunch of activities on a farm. The prompts that we get over here are very focused on the rooster. Rooster's behavior and training, rooster breeds, rooster's care and health. It happens to be a complete red herring, because if you watch the reel in question, it's basically to give flavor of what the farm is about. The individuals mentioned there are actually nothing to do with roosters. Like in this case, the rooster is a complete red herring to the experience. What we do see is that if we are able to bring in the creator or the author's context, in this case, it's a well-known horse farm. So being able to bring the author context, bringing in the comments, and then actually doing a web search, we are able to extract a lot more cultural grounding on what this farm is about and what they're trying to promote. Also, actually doing web searches on the two individuals visiting, we realized that they're actually well-known horse trainers and horseback riding experts. So by using all of these things, we're able to actually bring much more context and then apply a reasoning model on top of this to step through and figure out what would be interesting questions that users might have. Like, how do these individuals train the horses? What techniques do they use? Learning about horse training methods. That's what the post is really about. And the rooster is just to give you a flavor of a nice little farm. And in this case, these are the prompts that we actually end up getting. Moving on from this, so we had context understanding, we had reasoning models. Now let's take this to the next stage and bring in a bunch of agentic approaches. We've already done the hard work of collecting all the right context or setting up the right APIs or tool calls, but then how do we make sure that we get exactly the context that we need? Traditionally, your orchestration here is done via, like, you have a user query, you have a bunch of heuristics or rules, you have a predetermined set of context, like you're getting comments, you're doing a bunch of web searches, you're getting history of the author. All of this is more deterministic, and then you generate the response. Now, the challenge is that you can continue to add more context, but there is a point after which the performance actually starts to degrade. This happens because there's a finite token window, and the more context you're adding, you're running into a needle in the haystack problem. In the previous example, the rooster was a complete red herring. You're also making a bunch of calls, like the multimodal understanding in that case, which you actually don't end up using. And then finally, you have to continuously summarize this so that it fits into your context window. So this technique has these limitations, and we do need to kind of move on to agentic models, and which is what we end up doing here. So in this case, what we end up doing is, by leveraging a planning and adaptive context selection method, so having a planning model figure out what context it needs to pull, exposing these as tools, leveraging a protocol similar to MCP to call out to those specific context APIs that actually matter. And then once you have a good enough response to send back to the user, applying reflection techniques to make sure it's actually serving the user's need. So by bringing these steps in the way, you are not only saving not only getting a higher quality answer, you're also reducing your capacity costs by exactly calling the APIs you need to call, and also improves latency because you're not waiting for the highest latency context calls, which you don't end up actually using. So all of this actually improves and up-levels capacity, quality, and latency at the same time. But we can do better than this, and there are other problems that we have which we need to solve along the way in building retentive habits. So let's get into the next one. Let's talk about the role of auto judges here. So let me take you to the other challenge we see with agentic approaches. Often you will have a very interesting question here. For example, on this post, it's about how does Howard Stern decide to speak, or why did Howard Stern decide to speak about a certain topic? And if you look at the answer, the model is kind of equivocating. The model is effectively telling you that it doesn't know exactly the reason of why Howard Stern decides to speak about something. This is a refusal. We have refusals for various different reasons, but the most common ones we have is not having enough context, either having an infrastructure failure, or in some corner cases, also an integrity or safety problem. So some of these we can solve for, some of these we cannot solve for, but we have to work around them. The role of auto judges here actually helps us a lot. I mean, if we're able to tell some text as a refusal, then we can start to shift the inventory of what prompts we show to the user and start to get to a point where the number of refusals starts to go down. So when we started this, when we launched last year, we had offline evals and we had offline judges. So we combined like human rating and we combined automated evals. But the results of this, we were only able to apply back on fine-tuning of the model, and the fine-tuning cycles are often a couple of weeks long. So there is no real-time feedback loop for refusal detection and refusal and the improvements that you can get out of this. What we've done this year is actually move towards auto evals, which are online. So by going online, what we are able to do is evaluate at scale, but also have a real-time feedback pipeline. So using LLMs to detect that the response of the agentic model had a refusal helps us bring feedback back to future ranking of those prompts. So given a post, out of the candidate prompts we can show, we are able to assign a score for how likely it is to generate a refusal. And by doing that, we are then able to get to a point where we start to reduce the refusal prevalence on the product, and we see that that has a high correlation to retentive behaviors. Finally, let's talk about scaling all of these techniques. What we see is that because we have a pretty convenient power curve on Facebook, about 5% of posts end up generating between 35 and 50% of all impressions. It varies by language, but that's mostly true. Most of the posts that actually get high impressions early on end up dominating the number of impressions they get across the platform. Within that, the prompts that get the most engagement also tend to follow a smaller power curve. So what we can do is by focusing on those prompts and those posts that generate most of the impressions, we can try and start to cache results for these. Now, the challenge here is that caching requires you to select the right TTLs. And on Facebook, we have inventory like real-time sports. We also have recipes. A recipe question can have a very long TTL without impacting its quality, whereas a sports analysis or a live sports query needs to have a short TTL. So by leveraging LLMs to figure out the topic and the intent of the query, we're able to have an adaptive TTL. And by doing that, we're able to cache at scale. So for sports queries, we have a short TTL, whereas for a recipe query, we can have a much, much longer TTL. And by doing that, we're able to give you a much more quicker response and also reduce our capacity costs. And for those queries that are getting heavy hits, we can try and make sure we run more auto judges on them to ensure that they have a high quality. Let's take all of these things and put on our product hat and figure out how we can build retention from this. So some of this is around more general product building or product PMF building skills, and I'll talk about how we apply this for feed deep dives. We define the product funnel. We identify and understand the key cohorts for whom the funnel is very healthy. And then we identify key content types that are getting the most engagement. When we have all of these, and we pair that with what jobs the users are trying to achieve with the product, in this case, getting more context, or finding more engaging related inventory or related posts to consume. Once we identify those, we can start to double down on it. So by using metrics like CTR, click-through rate, that is, deep sessions, so how long the session was with the AI, looking at weekly active usage after n weeks, after let's say 90 days or 180 days, looking at whether we have a J-curve with a smile upwards, meaning that initially the user gets a lot more usage, then the usage drops, but long term, if we are starting to see users using them more and more, those are the cohorts we want to focus on. And then looking at L7ness, meaning like within the week, how many days of the week did the user end up using the product? So bringing this kind of funnel understanding, and then identifying feed usage patterns and feed deep dive usage patterns, we start to kind of push that data back into our AI agents to figure out which cohorts are getting the most value out of the product. And the users who are not getting enough value, we don't actually end up showing the product enough times to them. So effectively, whenever we show a pivot opportunity to the user, we want to be confident that they are actually going to get value out of clicking it. Otherwise, we don't want to disengage them from the rest of their feed experience. So that's how we get a balance on a product like feed. And this is how we start to do this. So traditionally, we have a bunch of user-to-user and user-to-media kind of models to figure out what users are getting value or what similar users are finding engaging. and which media or which posts they find engaging. This is our traditional kind of ML workflow. But we can actually go further here by bringing in LLMs and features which are around language understanding into the mix. So understanding the intent of queries, understanding what type of posts and what type of context within the post the user actually engages with. We're able to bring in a bunch of LLM-related features into the ranking models as well, and improve our U2U and U2M models to be able to target exactly those users and those posts for those users where we expect to see the most engagement. So that's all of the things that we've been doing so far. Let me talk about, summarize the key challenges and talk about what we are doing next. So I think these are the 3 key lessons. I think if you take only one slide out of this talk, this is the one. So what we learned last year was that having good context is important. So context is king. More context may be good, but actually having the right context is even better. So that's where the agentic models really help us get exactly the context we need. The other piece we learn is that at initial launch and when you're growing your user base, it's important to provide low latency. But as you start to get to a mature user base and users are using the product 3, 4, 5, 6, 7 times a week, you want to start focusing on higher quality, and users will tolerate latency once they've already built up the habits. So finding this curve of freshness versus latency starts to shift as you start to build retentive habits. What are we doing next? So 2 key themes for us. One is going on the path of monetization. The other one is going more social and going over the family and friends piece. So for monetization, we want to understand what particular prompts or what queries the users have, which have a monetizable intent within them. So there are people asking questions about the context of a post, but often people are looking for products and asking for product information. Those are very well monetizable queries. So bringing in the ad experiences here, while still focusing on privacy, becomes a big theme for us. The other piece is trying to bring in the social graph understanding, the family and friends understanding, so that we can open up more connection opportunities here, and bring in feed deep dives to posts where it's from a family or a friend who you haven't connected for a while, and find you opportunities to connect with them again. With that said, I think it's time for some questions, I suppose.
And the first question is, how do you balance capacity, latency, and freshness?
Yeah, I think this is a challenging question. There's only this much capacity we have available for all of us. I think initially what you want to do is focus on, when you're launching the product, you want to focus on making sure you're building initial retentive habits and using your capacity for a limited user base where you see signs of PMF. You start to then focus on latency so that for users who are using it, you're getting the response the first, second, third time quickly. But then as you build PMF and retentive behaviors, you start to rebalance that portfolio in the favor of quality, and you give a hit on latency. I think that would be my learning from this project.
Okay, and our second question is, how do we address the tension between refusals and hallucinations?
Yeah, I think these are you can have one or the other. So either you can have no refusals, in which case the model will be eager to find you an answer and often will hallucinate. On the other hand, if you want to cut down on refusals and ground on factuality, you will have the model, you want to cut down on hallucinations and make the response factual, you will have a model that refuses more. For a product like Feed Deep Dive, we do have the convenience to control what prompts or what queries we suggest to the user. So as we start to get more impressions, we are able to tell what leads to a refusal. And those are the prompts we start to reduce their prevalence. Because we control the suggestions, we are able to balance that. But for anybody building a general response model, this is a challenge. You can have refusals or you can have hallucinations.
Okay, thank you very much.
Thank you very much.
Please welcome to the stage
Whitney Curry, Jeff Brown, and Bai-Young Liu from Meta.
Right. Hello. Hi, guys. And thank you to everyone who made it to the end. You are champions. We're so glad you're here. My name is Whitney Curry, and I lead product marketing at Wearables focused on Meta AI. And I'm just delighted to be here today with two of my esteemed colleagues who are engineering leaders here at Meta, Jeff Brown and Bai-Young Liu. So I'm so glad they're here. And today in this panel, we are going to explore really what we're building here at Wearables and how we're thinking about wearables, what's going on and from an engineering complexity, and also in how we think about the approach of bringing products to market that really resonate with users in the real world, because ultimately that's what it's all about, impact to people in the day-to-day. So with that context, I'll now pass it to Jeff and Bai-Young for intros. Jeff, do you want to go first?
Sure thing. Thanks, Whitney. It's great to be here. So I'm Jeff Brown. I'm a software engineering manager here at Meta. And I currently support teams building AI experiences for our wearable devices. In my 7 years here at Meta, I've been fortunate to work on a number of different things, helping small businesses grow by working at the intersection of our ads and sales and support. I worked on building our camera software for some of our wearables product and computational photography to improve image quality, and now working on these AI experiences.
Hi, this is Bai-Young. I am a software engineer from Meta. So I've been with the company for 10 years, primarily focused on the AI glasses right now. All my time here, I've been building a voice assistant for Portal, Oculus, and all generation of AI glasses. In the last couple of years, I primarily focused on building the AI features for breaking language barrier, like live speech translation and live captions. It's my honor to be here.
These are the guys you want to be hearing from. 10 years, 7 years, this is it. All right, well, let's get down to business and talk shop. Now, we're focused at Meta, big picture, on building the deepest lineup of AI glasses in the world. And we want these glasses to add value and have application across multiple use cases. Our vision, big picture, is that this is the next computing platform. Similar to how basic cell phones evolved to smartphones, we have what one day I think we'll think of as analog AI glasses with the future AI glasses that are so much more complex in pursuit of personalized superintelligence. But that's not easy. That's a really complicated and technical challenge. And so Jeff and Bai-Young are going to walk us through how they think about that from an engineering perspective. So Jeff, why don't you go first?
Yeah, so for me, when we think about wearables and the challenges that we have for AI experiences, there are kind of two huge challenges that come to mind. The first one is the technical challenge that really comes inherent to the form factor. And so the way I kind of describe it is, if you think about it, we're going to face all of the challenges that you have in any AI product, but we're going to compress those challenges down into something that you can wear on your face. Right, which is very, very complicated. And so it's kind of, when you zoom out for a second and think about it, it's kind of crazy, right? But we do it, right? And we make it work. And so how do we do that is we're going to be able to leverage everything we can on the glasses themselves. We're going to take advantage of the phone, and we're going to take advantage of the cloud to be able to put systems together that really are able to deliver these experiences. The second challenge for me is really more of the customer or the user-centric problem. And so this is, if you look at wearables, it's a really nascent space, right? And so what is it that customers really want out of their wearable devices? And how do we intersect that with the technology that we have today so that we can build a really great product experience that, really meets their needs with what we want to do? And so wearables, to me, it presents these amazing opportunities, right? So one, it's super convenient. It is more socially acceptable than pulling your phone out in different situations. It has a camera that can see what you can see. It has microphones. It has audio that only you can hear. And so you're really able to create more immersive experiences for people that you just can't do today. And so, for example, something that you can do today with it, I was in Portugal last summer, and we were traveling. We were driving from Lisbon down to the coast. And so my Portuguese is best described as, I'd say, non-existent. And so reading the road signs was a little challenging. And so I was able to ask the glasses, hey, can you translate these road signs for me? And just as I'm driving, it's able to read off the road signs to me so that, you know, I'm not going to be going over the speed limit. I'm not going to miss my exit. So it's just that sort of capabilities that exist and make it worth solving those problems.
You know, that's such a great example. One, it just reminded me I want to go to Portugal. But two, Jeff, you were able to see the impact of your work in these walls out in the real world with your family on vacation. And for me, that's actually something that is one of the most unique parts about this job, working in reality labs on wearables, is the fact that so many people get to touch and feel the products that we're building. And that just feels really good.
Absolutely.
Your mom knows what you do.
Exactly.
Yeah.
And I think especially as people start to see with the display glasses, right, what a game changer it is for different use cases, like step-by-step instructions where you no longer have to stop what you're doing, put down your tools, go look at the instructions, but you're able to stay doing what you're able to do and see it overlaid on top of the work that you're doing. It just becomes a game changer from that. And for your people that you're with, to be able to see that, it's very tangible.
It's so cool. Well, I know someone who knows a little bit about those products you were using there, Jeff, which is Young. Tell us a little bit about what you're up to at Meta and some of the deep thinking that you're doing on some of our products.
Yeah, sure. I'm super excited about the future of AI glasses. I think that it's the perfect form factor for AI to equip our user with superpowers. As Jeff just mentioned, that you can see what you can see, you can hear what you can hear. It can just present the output in front of your eyes or next to your ears. I think we are really in the opportunity to build the next generation of computing platforms. However, as we all know, that building a consumer hardware, especially for older wearable like AI glasses, is super challenging. The first set of challenges is the hardware constraint and limited computational resources. So we want to do more with more powerful AI, which will consume more power, and will require a bigger battery, which make it heavier. So the user have to wear that all day. But at the meantime, we need to keep the lightweight and slimmer design of our glasses. So we need to maintain the high quality while optimizing our model, our systems, so they can fit into those limited compute constraints and run efficiently. And at the meantime, we keep pushing to reduce the power consumption of our features as much as possible. The second category of challenge I'm facing right now is how can we build an AI that is contextual, personalized, and always available next to you to help the user proactively or reactively. Different from the traditional voice assistant we usually know is that those type of AI feature has to be accessed or aware of the context around the user and be able to intelligently reasoning on top of it, say, what's the user intentions? Exactly. And then it has to complete much more complex tasks than we had before. Not just what's the weather. You can planning, have a lot of more exciting things to do it. Achieving such seamless experience requires the collaboration from computing on the glasses, on the phone, and on the server. Building these things together seamlessly, it has a huge systems design and optimization challenges. But from engineering perspective, it's kind of very exciting and interesting problem to tackle.
No big deal. Just another day at the office over here for these two. All right, changing gears. I want to dive into how you think about your team's philosophy for building some of these amazing products. And Jeff and I had the opportunity to work together earlier this year to launch a really fun feature called Restyle This that helps you transform what you're seeing using Meta AI image creation. And it's fun and warning addictive. But Jeff, it was great to work with you on that. And I'd love for you to walk the room through what some of those challenges were and your approach to doing that launch that was very quick, if I remember correctly.
It was. Thanks, Whitney. So the Restyle project just sort of started as this hackathon project that, again, the engineers kind of came up with to say, how do we take AI filters that are popular on Instagram or WhatsApp and make them work on glasses? And so when leadership saw this, they got excited. and said, hey, let's bring this to market and let's do it quickly. And so that's when I got involved in the project, and I think when you got involved.
That's right.
And so it really became this iterative process of bringing together the full XFN team to solve both the technical challenges as well as the product challenges and figure out how to create this really cohesive solution that was able to combine, again, something that is, from an engineering perspective, on the surface, relatively simple, right? You're taking an image, you're feeding it into a model with a prompt and getting another image back. But how do we really create a user experience that works on glasses for that? And so we had a lot of challenges to solve with that, but I think we came up with something that was cohesive through marketing, the product, and the technology tied together.
Yeah, you're right. It presented as like what could be a quick win, and we were able to do it quickly, but there were so many unexpected layers. I remember we got a little caught up on some like trust and privacy, just wanting to be really thoughtful there. Can you share a little bit more about that?
Yeah, so I think one of the things as we're building AI products, and that is always top of mind for us, is really privacy and safety. And so it's something that we need to build into every experience that we build. And so with something like where you're restyling images and allowing image capture, how do we think about, preventing the generation of obscene images? Or how do we think about handling pictures of youth, right? You may want to take a picture of your kids and restyle it, and that's okay. You may want to take another picture, and that's not okay. And so how do we handle this in the user experience? And again, a lot of thought and a lot of technology goes into that to make that part possible.
Oh, good. Well, I'm really proud of where we landed now that it's been in market a while. How's it been received? What's your take?
It's, I think, gotten a really good reception. So it's something that, right, thanks to our amazing team that worked on this, we were able to bring it to market and solve a number of different challenges in less than 4 months. We were originally targeting one product. We managed to launch it on 2 and bring additional capabilities along with it. It was actually showcased. We had a demo day with our board of directors to showcase a number of our AI features, and it was actually showcased to positive reception with our board. It was showcased at Connect last month. It's showcased with the Ray-Ban Meta Display glasses. And I think the general reception we get from press and people that use it is like, hey, this is just a lot of fun and a really great feature.
It's great. I just want to hit that point from ideation to in market to wowing the board of directors in 4 months. It's pretty cool for moving that fast at such a large company. So bravo to you, Jeff. And that was really fun to partner on.
Yeah, absolutely.
All right, Baiyang, now you aren't, bored off in the corner here. You've got a lot going on too. So I'd love to hear about a little bit more of your vision and the work you've been doing on live speech translation. Jeff mentioned he used it on his recent trip to Portugal, but there's so much more there. So tell us some more.
Yeah, break language barrier is always my passions, and I think Glasses has unique positions there. Let's talk about the live speech translation, which is I mainly focused over the last couple of years. Live speech translation is one of the most complex features I've ever worked on in my career. To give a little sense about the complexity and challenging we are facing, let's imagine a real user scenario, right? Imagine you are traveling in another country with another language that you don't know, have very limited internet access from your phone, whatever, and then you walk in a very busy street. You're trying to talk to another person and ask for the price about the product or ask for direction to a certain places. They will respond to you in another languages. And to achieve a seamless communication in such a scenario, the system have to do the following. Bear with me about the complexity. The system need to be able to identify who's talking and able to recognize and translate to another languages. At that case, there's a lot of people talking around you. There's a user talking next to the microphone, very strong signals. And there's other people talking to you in the far field, and a very similar speech signal around you, talking could be behind you, could next to you. We need to filter them out to focus on the conversations. The system need to recognize them, translate them, and also playing out the audio through the glasses to it. And all this happen in parallel simultaneously. To achieve this, we also need to handle all this complex processing on device in real time with low latency. Just by describing this, you can already see like, oh, it's complex to understanding it. But this comes with like several years of research and engineering to make this possible. We have very dedicated team from modeling, research, engineering, hardware, and product to build such experience to make it possible. So what we did there is that we have the glasses have 5 microphones here, that we beam from these 5 microphone audios into 13 directions.
Wait,
That's
I'm sorry,
12,
did you say 13 directions?
Yes, so
Whoa.
we got a 5 microphone array, capture the audios, and then we did beamform to 13 direction, where 12 direction around the clock, and 1 direction from the user's mouse. So with that, it's possible to canceling out the noises. However, instead of like a traditional method to choose particular beam directions, we feed all 13 directions into our model. And our model are able to train to intelligently to recognize the speaker and only return the results and translation results from the conversation and effectively ignore the conversation around you. Like behind you, side speech, noise, it will not get recognized. Only focus on this conversation angles. So we're using the model to identify those intelligently. To reduce latency. Latency is one of the most important things we always try to reduce for live translations, right? So all components in the pipeline are streaming. There's no like waiting for the turn finish and then processing it. Everything is streaming there. So the user are able to hear the translation contents from the audio while the other people are still talking. The smart glasses form factor have the unique position that they're able to let the user hear the translation content without interrupting the conversations. That is the uniqueness of this, and it's very essential for this kind of real-time communication in foreign languages. And again, all this happens on the glasses. So there's no network dependency on that. This is a huge challenge in here, but luckily the team made it and launched it to our product.
Gosh, that's so impressive. Just to think about all that went into that for you and your team.
It's a huge team collaboration across the company.
It's amazing. And you've been live, what now, like a year? How are things going? And are you going to continue innovating as we look into next year on this product?
Yeah, since the launch of the live speech translation on the Ray-Ban Meta glasses as the first one in the market, we have been busy to refine the experience. The job's not done yet. We expand this feature to all the AI glasses we recently launched, including the Oakley Vanguard glasses that we just launched yesterday, I believe. We also built a new experience on Meta Ray-Ban display. So instead of hearing the translation content from the audio on the Ray-Ban Meta glasses, you can directly see and view the translation content on the display. So it'll be much faster and easier to consume the conversations. We added more languages. We added German and Portuguese into the list. Of course, we continue to push in the boundary to improve the quality, improve the naturalness of the results, reduce the latency. The job's not done yet. We're still pushing the boundary on that.
So cool. I like the common theme of that product fostering connection. And that's something that we see really throughout so many of our features. Being in the product marketing org, we hear a lot from users who reach out unprompted to us and just are like saying, oh my gosh, this product's changed my life. Just a couple days ago, I heard from a dad of a 16-year-old who purchased the Ray-Ban Meta glasses for his son, who is severely dyslexic. And the story that he shared with our team was that for the first time ever, his son can now order independently at a restaurant. And that may seem like a small thing, but the dad was saying, you know, he's 16. He wants to feel like he can do things on his own. And because of the innovation here with hearing, with visual inputs, like that's made possible. So I just love how that intersects it, kind of the human impact at the heart of all that we're doing. I'm curious for each of you all, as you're thinking about your work and the products you're building, does the accessibility angle play a role? And if so, how?
Yeah. I always think the glasses can bring a lot of social good to our user. We hear a lot of story from our users, even though we did not really market it that way. So built on top of the live speech translation technology we built it, the the new Meta Ray-Ban display offer real-time captions of our conversations. Thanks to the technology we have, it actually works pretty robustly in noisy environments, and it also can provide some help to the user who has some difficult hearing. Boz and Mark demoed this feature in the Connect events last month. So I think that really brings a lot of value to our user. I'm super excited to learn what kind of things that the user can do with those technology to improve their lives.
Am I the only one who watches TV in their home with captions? Can I get a hand? I mean, I can't be the only one. Thank you. You are my people. And we have this feature for you to be able to have captions on daily conversation. I cannot wait for that. Jeff, what about you?
Yeah, so I think for me, initially, I didn't really think about that area too much. But as you hear the stories, you start to realize the power that this technology has for these different communities. And so it definitely, you also realize the importance, right, in our role in bringing these capabilities to these communities. And so one of the things that's important for me is making sure that our team is really getting out there and engaging in user research and understanding and building empathy for these people. And what we learn is, again, from that, we're able to build better products because we a lot of times learn what we think is the solution to those problems aren't actually exactly what they need. And I'll give the live captions as an example. Just providing an accurate transcription and low latency certainly solves part of the problem, but one of the things we learn is, hey, you're missing sort of the tone and the emotion that is coming along with those words. And so how do we now go and solve that problem to, again, take the products to another level?
Really important. Now, we're getting short on time here, so as we wrap up, we've talked a lot about the highlights, but there's obviously lowlights that come as the counterbalance to that, and I know you guys have ambitious plans for 2026, so what are some of the things that you're struggling with, or those big rocks that you're really hoping to overcome as we think about what's next?
Ben, you want to go first?
Yes, sure. I think our job's not done yet, as we see that we want to cover more languages. There's a lot of language in the world, so we want to continue pushing to cover more and more languages, scale of that. Naturalness, semantic translation rather than word-to-word translation is critical for us. So we continue to push into technology to see whether we can leverage a bigger model, much better model to translate much more natural rather than literal. But besides that, I'm super excited about the display. So I think with display and neural band control, we can really provide much more discrete, non-intrusive, less intrusive kind of experience to help our user. I'm looking forward to building more application and make the more AI utility functionality to our AI glasses users.
Such a good point, how the glasses can actually unlock your ability to have an expanded state of presence. Such a good point. And Jeff, bring us home.
Yeah, so I know I'm standing between you and happy hour, so I'll give you two big rocks, boulders, however big you want to be, we're going to move them. So the two for me that are extremely top of mind, so the first one is when we think about the vision of hands-free computing and we take these things that we've created, how do we deliver a step change in the capabilities and the value that we're providing to users? So using Restyle This as an example, right, where we're able to restyle photos, how do we take that and deliver something that really is more of a true hands-free editing capability? So it's all about delivering that step change and delivering on the promise of hands-free computing. And so then the other challenge for me is, again, if you look, 2 years ago, we delivered one product. Last year, we delivered 5. I'm pretty sure they're not going to ask us to deliver less going forward, right? And so we need to be able to move faster. And so for me, as an engineering manager, right, how do we hire and bring in the best people to help us do that? And then 2, how do we really create a culture that allows us to do that, right? So that people are set up for success, so that they're able to move quickly, and we're really able to scale, right? Both in terms of and maintain quality in the things that we do and the products that we deliver. So I think that's, again, another huge challenge outside of just the technical domain that we have that we need to solve so that we're able to deliver on this.
What a great note to end on. Well, if these are the types of challenges that you find energizing and the type of people who you think would be fun to work with, we'd love to have you here around the halls with us at Meta. So thank you for your time, and we will hopefully see you milling around at happy hour.
Cool.
Thank you.
All right.
Thank you.
All right. That concludes our event for today. How do y'all feel? So before we join, everyone goes out for happy hour. Before you join us there, I wanted to just a couple housekeeping things. There's going to be 2 more videos on demand from SEMA Labs and Microsoft on AtScale conference website, the AtScale YouTube channel, as well as the AtScale Facebook page. All the talks from today are also going to be there, and there'll be a couple blog posts coming out within the next few days. And again, we're super excited to have you here. Please follow us, LinkedIn, Instagram, etc. And yeah, thanks for having me as your host, and see you out there in happy hour.